This is R.D. Sharma Solution Class 12, Chapter 5, Algebra of Matrices. Exercise is 5.3. Compute the indicated products. So we have to multiply two matrices. So how do we do this? There is a proper procedure. We'll do a few of them directly and one by one, that is AB minus BA. Then we have the second matrix, which is A minus B, B and A. So we'll take the first row of the first matrix and then the columns of the second matrix. Okay. And then we take the second row and then we follow that same procedure. So first of all, the order have to be seen and the column of the second matrix should be equal to the row of the first matrix. And the result will be the row number of first matrix and the column number of second matrix. So first row of and the first column. So A multiplied by A. Then B multiplied by B, and you have to add this. Now keep this row till all the columns are finished. This is the second column. So A into minus B plus minus B into A. This is B, not minus B, sorry. B into A. Then we have to move down. That is, the second row has to be done exactly the same way with both the columns. So minus B into A plus A into B. Then again the same row with the second column. That is minus B into minus B plus A into A. So what do you get? This is A square, this is B square. So A square plus B square. This is minus AB plus AB, that is going to give you minus AB plus AB, that is going to give you 0. Then we have minus BA and plus AB, again 0, and minus B square is B square and A square is A square. So A square plus B square you get. So this is your answer. Okay, I hope you're able to do this. I'm clearing it now. Let us go for the second one. You have to see the order. This is 2 by 2 matrix and this is 2 by 3 matrix. So since these both are same, the multiplication is possible. And the answer will be 2 cross 3. So I'll just do one by one. Okay, I'll just directly do it. First row and the first row of the first matrix and first column of the second matrix. So 1 into 1 plus minus 2 into minus 3, that is going to be 6. Now same row with the second column. 1 into 2, 2. 2 into minus 2 is minus 4. Then same row with the third column. 3 into 1 plus minus 2 into minus 1, that is going to be 2. Okay. Right? Now coming to this one. Now the second row with all these three columns. 2 into 1, 2. 3 into minus 3 is minus 9. Then 2 into 2, 4. 3 into 2, 6. Then 2 into 3, 6. And 3 into minus 1 is minus 3. What do you get? You get 7. Minus 2, 5. Then 2 minus 9 is negative 7. This is 10. This is 3. Okay. Now third one also I'll do because most of the questions are based on the multiplication. So I have to do all these so that I can skip the others in later part. So now first row of the first matrix and the first column of the second matrix. Right. So 2 into 1. I'm doing it directly. 2 into 1 plus 3 into 0 plus 4 into 3. Now the same row, this is 3 by 3 matrix, this is 3 by 3 matrix. So the multiplication is possible and also the result will come as 3 by 3. Now the first row with the second column. So 2 into minus 3 plus 3 into 2, that is 6, and plus 4 into 0. Now same first row with the third column. 2 into 5 plus 3 into 4 plus 4 into 5. Okay. And now the second row, this second row with all these three columns. 3 into 1 plus 4 into 0 plus 5 into 3. Then the second row with the second column. 3 into minus 3 plus 4 into 2 plus 5 into 0. Then the second row with the third column. 3 into 5 plus 4 into 4 plus 5 into 5. Then the third row with all the columns. 4 into 1 plus 5 into 0 plus 6 into 3, 4 into negative 3, 4 into 2, 5 into 2, sorry, 6 into 0. Now third one, 4 into 5, 5 into 4, and 6 into 5. Okay, so 2, this is 0, this is 12. I'm writing it directly. 12 plus 2 is 14. Minus 6, this is 6, and this is 0. 6 minus 6 is 0. Okay, then 5 into 2, 10, 4, 12, and 5 for the 20. 20, 12, 10 is going to be 42. 3, this is 0, this is 15. This is going to be 18. This is minus 9, this is 8, this is 0. 8 minus 9 is negative 1. 15, 16, and 25. So what do you get? This is going to be 56. This is 4, this is 0, this is 18. That is 22. Minus 12, 10, and 0. That is going to be minus 2. What was the 20, then 20, then 5, 6 are 30. So it will be 70. Okay, this is the matrix multiplication of all these examples. Show that AB is not equal to BA in each of the following cases. So as we have already seen about the multiplication now, I hope you'll be able to do it. So we'll take one of these just to prove the idea, just to prove what they are expecting. So we'll take the first one, and second and third, the solution is also given, but I'll show you how this has to be done. The A and this B I'm taking, this is 5, negative 1, 6, 7. This is 2, 1, 3, and 4. So this row, first row, and this column, first row and first column. So 5 into 2 plus 3 into minus 1. Now same row with the second column, 5 into 1 plus 4 into negative 1. So that is negative 4. Now the second row with the first column, 6 2s are 12 and 7 3s are 21. Now the second row with the second column, 6 into 1 plus 7 4s are 28. Okay. So what do you get? 5 2s are 10, 10 minus 3 is going to be 7, 5 minus 4 is 1, 21, 12 is 33, and this is 28 plus 6, 34. So this is A, this is B. Now this is A cross B. We'll do it same for B cross A, same multiplication, but now B multiplied by A. And normally AB is not equal to BA. You will see it. So this is B and A now. 2, 1, 3, 4. This is 5 minus 1, 6, 7. So first row and first column. So 2 into 5 plus 6 into 1. Then 2 into the first row, second column. 2 into negative 1 and 7 into 1. Then second row, first column. 3 into 5 plus 6 into 4. Then second row and second column. 3 into 4, 3 into minus 1 plus 7 into 4. So 5 is a 10, 10 plus 6. So 10 plus 6 is going to be 16. And then we have minus 2 plus 7. That is going to be 5. Then 15 plus 20. 24. Sorry. It's going to be 39. Then we have negative 3 plus 7 4 is 28. 28 minus 3 is 25. So this is our final answer because AB is not equal to BA. So this is you have to do it for all the second and third also. This one. Okay, let me clear it and let me show you what you have to do. Second and third, exactly same way you have to do it. Third one, compute the product AB and BA whichever exists in each of the following cases. So I hope you'll be able to do AB and BA. Let me tell you whether it is existing or not. The first one is 2 by 2, the second one is 2 by 3, and this is A and B. So A cross B, because the column of first matrix is equal to row of second matrix, it is possible. Now B into A, because 3 and 2 are not equal here, so B is not possible. So AB is possible, which you will be able to do. I hope. I'm pretty sure about that. Then this one, this is A and B. This is 3 rows and 2 columns. So 3 cross 2. Here we have 2 rows and 3 columns. So 2 cross 3. Since this 2 and 2 are equal, then AB is possible. How about BA? What is B cross A? Let us say see B is 2 by 3 and then BA, let me just write it. B is 2 by 3, A is 3 by 2. Since 3 are equal, so this BA is also possible. So you have to do it for this one also. Okay. So there's one more example which is given. You escape it or you can just do it. AB is not equal to BA. We have already done a question like this. So just go back to that question, have an idea. Just find out the A and B multiplication and B and A multiplication. You will definitely find they are not equal. So, this is a very big exercise. So I'm just skipping which we have already done. Wherever the logic, reasoning or some discussion is required, we'll definitely do that. So what we have to do here is we have to add these two matrices, multiply. Here we have to multiply all these three matrices. And in the third one, we have to multiply this with the subtraction of these two matrices, right? So the second one I'm going to do, you have to do for the first and third, I'll just tell you. This is 1 and 3. So you'll get 3 and this 1, -1, 0. -2, sorry. -4, 1 is -3. Now multiply this with 1, 3, 5, 2, 4, 6. I just added two matrices and try to multiply. Now this multiplication you'll be able to do. Okay. So this is the answer. Now the third one I'm showing you. The first one you have to write like that only. That is 1, -1, 0, 2, 2, 3. And then you have to subtract these two matrices and multiply that matrix with the first matrix. So I'm just subtracting here. 1 minus 0 is 1. 0 minus 1 is -1. 2 minus 2 is 0. Then 2 minus 1 is 1. 0 minus 0 is 0. 1 minus 2 is -1. Now just multiply these two. I hope you'll be able to do it. Now third one, which is this multiplication, we'll do it here. Is it possible or not? We'll just see. So this is, how many rows are there? 1 row, 3 columns. Here we have 3 rows, 3 columns. So the multiplication is possible and the result will be 1 cross 3. So let me do it. 1, 2, 3. Then we have this 1, 2, 1, 0, 2, 2, 0, 1, 0, 1, 2. Okay. This row with this column. So 1 into 1, 2 into 2, and 3 into 0. The first row with first column. Then same row with the second column. So 1 into 0, because the result will be 1 into 3. And there will be only 1 row and 3 columns. So this is 0 plus 2 into 0 is 0, 3 into 1 is 3. Now first row and third column, 1 into 2, and then 2 into 1, and 3 into 2. So 5, 3, and 6, 7, 10. Okay, 5, 3, 10 is the result. And now we have to multiply it with 2, 5, 6. 2, 4, 6. So this is 1 into 3 and this is 3 into 1. 3 row, 1 column. So there will be only 1 entry in the final multiplication. Only 1 by 1 by 1. That is 1 row, 1 column. Only 1 entry will be there. Okay, 5 into 2 is there. 3 into 4. And then 10 into 6. Just add them. What do you get? This is 10. This is 12. This is 60. 60, 70, 70, 80, 82. 82 will be the result. Okay, I hope you will be able to do the first and third one. Any problem, the solution is there. Just have a look. Okay, now A is this, B is this, C is this, and A squared, B squared, and C squared has to be equal to I2. We have to show that. Now you just have to square it. That is, you have to multiply this A matrix twice. That is, it has to be equal to I2. I2 is identity matrix. That is 2 by 2. There is 2 row, 2 column. So I'll just show you the first one, either A square, B square, or C square, and you have to do for other two. So I'm just taking A. A square is A dot A. So this is 1, 0, 0, 1. Just multiply these two. I hope you'll be able to multiply it. Just for the sake of completion, I'm multiplying it. 1 into 1 is 1, 0 into 0, 0. Then first row, second column, 1 into 0, 0, 0 plus 0 into 1 is 0. 0 into 1, this second row and first column, 0 into 1 and 1 into 0. Again 0. Now the second row with the second column, 0 and 1. So what do you get? You get 1, 0, 0, 1, and this is going to be an identity matrix. 2 cross 2. So same thing you have to do for B cross, B square, and then for the C square. And they all will come as the identity matrix, which is I2. This is C, okay? Now A, B is given. This is CBSE 2005. We have to find out 3A square minus 2B plus I. Now A square will do. And we'll put B here, an identity matrix. Let me do the A square first. This is 2, -1, 3, and 2. This is A. We are doing A square. So just multiply these two. 2, -1, 3, 2. Okay, first row, first column. 2 into 2, 4. And -3, -3. So this is -3. First row, second column. First row, second column. 2 into -1. And then -1 into 2. That is -2. Then 3 into 2, second row, first column, 3 into 2 and 3 into 2, 6, 6. Then second row and second column, 3 into minus 1 and 2 into 2. So this is a squared. This is going to be 1, this is negative 4, 6, 6, 12, and then this is 4 minus 3 is 1. So this is a square. Now multiply this with 3. This is a square multiplied with 3. I'm multiplying here only. So I'm just writing 3 into 3 ones are 3, 3 12s are 36, 3 4s are 12, and 3 1s are 3. So this is the result. And then we have just multiply twice. I mean, these 2 with this and write it here. 2 0 0, 2 4 0, 8. I'm multiplying whole matrix by 2, scalar multiplication. Negative 2 and 14. Okay, then plus I. What is I? I. Say I is the identity matrix. So identity matrix is just all the ones in the diagonal. So this is since 2 by 2. This is 1 1 0 0 here. And now we have already done all the a square. We have found out 2b and 3a square and I. Now I'm just adding it. What do we got? 36 minus 12 and 3 and minus 2b. We have already done this. So this will be 0, 8, and negative 2 and 14. Then identity matrix. Identity matrix is simply, as I said, the diagonal 1 1 will be there. Okay. Now just directly do it. 3 minus 0 and then 3 minus 0 plus 1. Then minus 12 minus 8 plus 0. Then the second row, 36 minus 1 minus 2 is plus 2, and then we have 0. Then 3 minus 14, and then we have plus 1. Okay, 3 plus 1 is 4, this is minus 20, this is 38, this is negative 10. Okay, this is the final result. This is question where we have to use this A and B matrices in a kind of equation. Similarly here also, if you multiply these two, there will be an equation. So what we have to do here is we have to find out A squared. Main thing is A squared. So just multiply this A, these two matrices, A into A. So you have 2, negative 1, 3, 2. And then same thing you have to write again. And just multiply the way I already taught you. This row, this column, 1 by 1 element, 2 2s are 4, and 3 minus 3. Then this row, this column, 2 minus 1, that is 2 minus 2. This is also minus 2. Now this second row with first column, 3 2s are 6, and 3 2s are 6, 6 plus 6. Now the second row with the second column. So 3 into minus 1 is negative 3, and 2 into 2 is 4. Okay. So this is A squared. What it is? 1, negative 4, 12, and 1. Now you just have to put it here. So we have to multiply it by 3 because it is 3a squared. Multiply it, 3a squared, 3 into, this is 3, this is 36, this is minus 4 is minus 12, 3 into 1 is 3. Okay. The minus 2b, now multiply this matrix with 2. So I'm multiplying each and every element with 2, 0, 4, negative 2, and 14. So it is negative 2, okay. This is 2 by 2 matrix, this is also 2 by 2 matrix. So what is I2? See, 1, this is, the diagonal has to be 1, others has to be 0. So this is the final thing. Okay, now we'll just directly do it because there just has to be element addition and subtraction. So this is negative 2. I'm just now I'm writing it at once. So 3 minus 0 plus 1. Then negative 12 minus 8 plus 0. 36 minus 1 minus 2, that is 36 plus 2. And this plus 0. 3 minus 14 plus 1. Okay, so 3 plus 1 is 4, minus 12 minus 8 minus 20. This is 38, this is minus 10 because it is 4 minus 14 minus 10. So this will be the final answer. And this is also same, just take A as 4 to negative 1, 1. Okay. And then you have to subtract twice of I. What does that mean? I is what? It is, because it is 2 by 2 matrix, I also has to be 2 by 2 matrix. So 1 0 0 1. Twice is what? Multiply this with 2, 2. So 2002 like this. Then we have A again. That is 4, 2, negative 1, 1. And now you have to multiply it by 3. Multiply it by 3. 3i. So you get 3, 0, 0, 3 like this. Okay. Okay. 4 minus 2 is 2. 2 minus 0, 2. Minus 1 minus 0 is negative 1. 1 minus 2 is negative 1. And the next one. 4 minus 3, 1. 2 minus 0, 2. Minus 1 minus 0, minus 1. 1 minus 3 is negative 2. So multiply. 2 into 2. 2 into minus 1. 4 2 into 2, 4. 2 into minus 2. Then negative 1 into 1. And then negative 1 into negative 1 is plus 1. Okay. Negative 1 into 2. Negative 2 into 2 and 2 into 1. So you get this as 0, 0, 0. Oh, everything is 0. That is what we wanted. This is the identity matrix. Okay. Oh, sorry, null matrix. So you have A square and A cube you have to find out. So this is A. Just pick A square. That is multiply A with A. This is your A square. Then you have A cube. Multiply A 3 times. Again you have to multiply the result. So this will be the answer. So we have already seen just now a question. And I just skipped it because here I am going to show you how this A square will be computed. Let us do it. This is AB, B square. I am doing it and I will show you that it is going to be 0, 0, 0, 0, null matrix. So we are multiplying A square means multiplying A twice. A cube is multiplying A thrice, 3 times. So we are multiplying twice here. AB into AB. Then plus B square minus A square. This row, this column. Now the first row and second column. AB into B square. B square minus AB. Minus A square. The second row with the first column. Minus A square AB. And then minus AB A square. So minus minus plus. Now this row and this column. So minus A square B square plus this is AB AB. Okay. So this is A square B square. This is minus A square B square. This is AB cube minus AB cube. This is minus A cube B plus B A cube. This is also at 0. Minus A square B square minus A square B square. So this also goes 0. So you get a 0 here. So when you do A cube, whenever it is being said, the final answer has to be multiplied by A again. I'll do A square this again. This is CBSE 2000. So since trigonometry is involved here, so we have to have a bit idea about the trigonometric expressions and the inequalities, equalities, etc. So cos 2 theta, sin 2 theta minus sin 2 theta and cos 2 theta, let's multiply it A and A again and again. Means 2 A's, just take the matrix multiplication. This is cos 2 theta minus sin 2 theta, sin 2 theta and cos 2 theta. So now the first row with the first column, then this first row with the second column. So cos 2 theta into cos 2 theta minus sin 2 theta into sin 2 theta. Now the first row with the second column. Cos 2 theta, sin 2 theta and sin 2 theta and cos 2 theta. Multiply them and add them. Now the second row with the first column. Minus sin 2 theta and cos 2 theta. Then cos 2 theta and minus sin 2 theta. Now the second row with the second column. Minus sin 2 theta, sin 2 theta. That is going to be square. Cos 2 theta and cos 2 theta again. Just write cos square 2 theta. Please remember all are 2 thetas. So whatever will be the result, it will be 2 theta. So this is cos square theta minus sin square theta. Cos square theta minus sin square theta is what? Cos 2 theta. Since it is already 2 theta, it will be 2 into 2 theta, that is 4 theta. So cos 4 theta it will be. This is sin theta, sin 2 theta, cos 2 theta. That will be twice of sin 2 theta, cos 2 theta. And 2 sin 2 theta, cos 2 theta is what? Sin 2 theta. As I said, theta is already twice. It will be sin 4 theta. Sin 4 theta. So this happens here also. Take minus outside, it will be plus. It will be similar to the second, the second element of the first row. That will be sin 4 theta only. That's just, it will be negative. What is this? Cos square theta minus sin square 2 theta. So that is again, similar to this one. So cos 4 theta. This is going to be the a square. A is given, B is given. AB into BA is null matrix 3 by 3. The answer has to be 0, 0, 0, 0, 0, 0, 0, 0, 0. This has to be the final answer. So we have AB and BA. Same kind of questions here we have. This 12th one and the green one. So one of them will do, because here we have numbers, proper numbers, integers you can say. And here we have some variables. So let us do one of them so that we get a fair idea about how to solve it. So I'm gonna do this one, and at least I have to show you how A and A dot B will be done. So I'm writing A here, and we'll perform A and B matrix multiplication. And you'll see that it will be equal to 0. Similarly, BA, I'll just leave it for you, but let me do it first. See, because it takes time, it takes some time. Okay. So now the matrix multiplication has to be done. When we replace A by B, it means A into B and B into A, this things remain unchanged. 0, 0, 0 will be result. So first row, first column. 0 into A square, 0 C into AB is ABC. Then minus B into AC is minus ABC. Now first row, second column. It's very simple matrix multiplication. Just you have to worry about these signs. Signs may create some, sometimes you miss the sign and the answer you won't get. So what are you going to do? First row with all the 3 columns on the right hand side. Then second row with all the column on the second matrix. Then third row of the first matrix multiplying with every column of the second matrix. So I'm doing one by one now. So this is first row with third column I am performing now. Okay. What do you see? Here only you can see ABC minus ABC is 0. B square C minus B square C is 0. BC square minus BC square is 0. First row is already 0, which I can see. Now minus CA square plus 0 plus A square C again 0. The second row with the second column. Minus ABC plus 0 plus ABC. Now second row with the third column. Minus AC square plus 0 plus AC square. Now the third row with all these 3 columns. So as I was just suggesting you, that it will take some time to solve this. So what we have to do is, I'll just show you A into B. The previous question and this question, you have to perform same way. You have to perform B also. And just be very careful about the signs and the computation, because the computation only takes the time. Otherwise, if you understand the procedure of matrix multiplication, there will be no problem in solving it. So what I'm trying to show you here, that every element which I computed is becoming 0, 0, 0. Like B square minus A, this is also B. Every element, like A square B minus A square B. Last one is ABC minus ABC. So everything is 0. Now same thing you have to do B cross A, and eventually you will get a 0, 0, 0 null matrix. So same these two you are going to perform. Same here. AB will be not 0 here. It will come back again to A. And when you do BA, it will come back again to B. Right? A and B. So what you have to do? Multiply A with A. Then multiply B with B and subtract it. So A into A you have to do. This is A square, A dot A. Then you have B square, that is B dot B. B square you will get. Now A square minus B square is what you got first, A square and B square, you just have to subtract it. The final answer you can see here. There is only one thing I would like to tell you here. That is A square. Why do you want to do A square and B square? There will be 2 multiplication. But here, if you do A square minus B square as A minus B, A plus B, it will be only one multiplication. That is, first add these 2 matrices and subtract these 2 matrices, and finally multiply them. So there will be only one matrix multiplication. That you can also do. For the following matrices, verify the associativity of matrix multiplication. As we already suggested, the matrix multiplication is associative. That is, when you multiply AB first or BC first in the multiplication of ABC, the result remains unchanged. It will be same, right? So first we are doing AB, then multiply it with C. Second we multiply BC and then we multiply it with A. And as I just suggested, the result won't change here. It is called the associativity of matrix multiplication. AB and BA, if you multiply, they won't be able to give the equal answer. They are not equal. But when you are multiplying in series, you can take any order. For the following matrices, verify the distribution of a matrix multiplication over matrix. So, I am just giving you an example. 2 into 3 plus 4. What does it mean? 2 into 7, 14. So, 2 into 3 plus 4 is 2 into 3 plus 2 into 4. What are you going to get? 6 plus 8, that is 14. This is what you have to do here. So I hope you'll be able to do it, okay? Just add B and C, multiply it with A. Second time, multiply AB, multiply AC and add them. And let me assure you, the answer will be same because the matrix multiplication over matrix addition is distributive. You can verify this distributivity. Same here. That is, subtract C from B, multiply with A, or multiply AB and multiply A and then subtract them. Both answer will be similar. Matrix, subtraction and addition you have to do, and multiplication we have already seen how to do it. Okay, compute the elements A32 and A22. So first we have to multiply. And whichever result is going to come, we have to pick certain elements from that final matrix. The first one is 4 by 3, the second is 3 by 2, the third one is 2 and 5 columns here. 2 into 5. So this, when you multiply this, the result will be 4 cross 2. When you multiply 4 cross 2 with 2 cross 5, 2 gets cancelled, it will be 4 cross 5. So finally, it will be 4 cross 5 matrix. And when you finally get to the answer 4 cross 5, what do you get? This is 4 cross 5. 4 rows and 5 columns. So you'll get A43 also, A22 also. Let me just make that final matrix for you. A11, A12, A13, A14, A15, here A21, A22, A23, A24, A25, A31, A32, A33, A34, A35, A41, A42, A43, A44, A45. Now what you have to find out? See, let me just mark it. There are 2 elements we have to compute. Find out after computation. A43 and A22. These are 2 marks which we have to find out. So let me just show you how to multiply it. So when you multiply these 2, okay. So there are so many questions which we have to do. So I'll just show you how we have to multiply because matrix multiplication is quite clear to you. So first we multiply, either you multiply the first 2 or the latter 2. It's up to you. So this is the value A22 and what is A43? 4th row, 3rd column. This is A43. So this is A22 and this is A43. I hope you'll be able to do the multiplication, right? Now, if A is equal to this matrix and I is the identity matrix of order 3, we have to show that A cube is equal to P into I plus Q into A plus R into A square. So these kind of questions are coming, in the later parts also. So we have to find out A cube. So I'll just try to tell you what is A cube. We'll multiply A thrice, 3 times. And I is the identity matrix of order 3, that is 3 ones in the diagonal. So we are going to do A dot A and the result you also have to multiply A again. So I'm going to just show you the first part. That is, we are trying to find out the A squared. A squared is this 0, 1, 0, 0, 0, 1 PQR. This is A. And again A we are putting 0, 1, 0, 0, 0, 1 and PQR. So you know how to multiply now. By now this row, this column. So what do you get? See, 0 into 0, leave it, 1 into 0, leave it, and p into 0, leave it. So all will be this 0. Okay, everything is 0. There is I just written p, I guess, so I'll just remove it. First row, second column. So first row, second column, again leave 0, 0, and again 0 will come. The third will come as 1. Okay. See, in the second row, all the first element will be 0. So just write the last row of the second matrix, PQ, and you write R. Now, this row and this column. So 0, 0 is there. So only R into P will come. Next one is this P will come, Q will be 0, and Q square will come. So P plus RQ. So R, this is RP. Then we have RQ, P plus RQ. Then we have P0, Q, and R square, Q plus R square. Now this is not done. This is A square. Now we'll put it here, but we have to find out A cube also. So A cube, we'll multiply this again with A. That is, again write 0, 1, 0, 0, 0, 1, PQR, and then multiply. This is the final result of A cube. So it will take some time. So I'll just show you the final result. I hope you'll be able to do. I'm just showing you the final result. You know, row with column, first row with all the 3 columns, then increase the row numbers, and that is how you do. Let me write the final values. A cube is like this. So P, RP, PQR, RP, P plus RQ, Q plus R square, PQ plus R square, P, RP plus Q square plus R square, P, R square Q, and P plus 2RQ and RQ. So let me write these values on the right hand side. So we'll try to show that will come as A cube. So P into I, what is the diagonal matrix? It will be diagonal, all 3 values will be 1, 1, 1. This is your P. Then you have Q into A. What is A? Again the same matrix, 0, 1, 0, 0, 0, 1, PQR. And then we have plus R into A square. A square we already found out. So this matrix I'm writing here, I'm not putting it here, but I'm just telling you, we will multiply R and then we'll write it. So let us multiply P with this matrix. So all 1, 1 value will become P. So only the diagonal values will be P. And all the values are Q now. Just leave the 0 ones, 0, 0 like that. Q into 1 is Q, 0, 0 is Q, and PQ, Q square, and RQ. And what about this one? Now you just have to write everything here multiplied by R. So let me first add these two, P plus 0. Third element I am taking from here, plus I am multiplying R with the A squared, and I am writing it here. Okay, so I'm multiplying R. So let me just write it here only. Let us write it here so that we just have a fair idea. I am writing this. I'm multiplying it by R by itself. Just this A square we have already computed. Okay, so this is R into P. It will be 0. This 0, 0, 0. I told you earlier also. This is 0. So I'm just changing it because 0, 0, all are zeros. So okay, rest things are okay, but the first one I just changed it, so it is 0. So R into 0, it is going to give you so R into 0 going to be 0 only. Then R into 0 again 0. R into 1 is going to be R. And then we have RP, and this is going to be RQ, and this is going to be R square. This is R square P, then RP plus R square Q. Third thing I am writing here, RQ plus RQ. Now I am adding P plus 0, P plus 0 plus 0. So P plus 0 plus 0 will be the first entry. Then we have 0 plus Q, 0 plus Q plus 0. Then it will be 0 plus 0 plus R. Next one, 0 plus 0 plus RP. Then we have P plus 0 plus RQ. Then we have 0 plus Q plus R square. The third one, this is 0 plus PQ plus R square P. Then we have 0 plus Q square plus rp plus r square q. Rp plus r square q. Then the third one, last one is p plus qr or rq plus rq plus rq. Now this value, just see what it is coming. So just forget about the 0. I'm not going to write it again. I'm just showing you. So this a cube was, as I said, it has to come as a cube. So is it equal? See, this is p, this is q, this is rp, this is rq, this is r square. This p plus rq plus q plus r square. This is pq plus r square p. This is rp plus q square plus r square q. This is p plus rq and rq is 2rq. So p plus 2rq plus rq. Next one is, if omega is complex cube root of unity, show that. So before I go ahead, let me give you an idea here that these cube root of unity, they have certain relationship. 1 plus omega square is equal to 0 and omega cube is equal to 1. There are two ways to solve this. Both ways you can do it. So I'm adding it first. Two matrices have to be added, 1 plus omega, then omega plus omega square plus 1. Then omega plus omega square, then omega square plus 1. So omega square plus 1. Then we have 1 plus omega. 1 plus omega. Third one, the omega square plus omega. Then 1 plus omega square. Then omega plus 1. Third one is omega plus 1. It is not omega square, it is omega plus 1. Okay, I'll just change it. So either you write it all and multiply it with 1 omega square. That will take a bit time, or I'll just use the identity to make it simpler, a bit simpler. Ultimately you have to multiply a whole thing. I'm just saying that I'm just trying to make it easier. So only one thing I need to change. The last one is omega plus 1, not omega square plus 1. So I just changed it. Okay. So let us use the identity. The multiplication will be simpler. So I'll use this 1 plus omega square and omega cube equals 1 in order to make it some simpler, because 1 plus omega is what? Minus omega square. 1 plus omega is minus omega square. So omega cube is 1. We know this. Let me show you again. 1 plus, we'll just try to write the final value. 1 plus omega is minus omega square. Omega plus omega square is going to be equal to 1 plus omega square is what? 0. So omega plus omega square will be what? Negative 1. Write it negative 1. Omega square plus 1, it will be equal to minus omega. Then we have this one. Omega plus omega square, it is going to be negative 1. 1 plus omega square, it is going to be minus omega. 1 plus omega is minus omega square. Omega square plus omega is minus 1. 1 plus omega square is minus omega. And 1 plus omega is minus omega square. Since all the values are negative, you can take minus 1 common. It will make your computation easier. But if you want to keep it like that, that is also possible. I'll do with negative sign on, but I would strongly suggest you to take the negative sign outside. I'm doing it directly. So minus omega square into 1 plus omega into minus 1 plus omega square into omega. That is omega cube. Coming to the second one. Minus 1, minus 1, 1, 1, minus 1, minus omega and omega square, minus omega square and omega minus, or this minus omega to the power 4. Right? Minus 1, then we have this minus omega square minus omega to the power 4. So when you will learn determinant, if two rows of the determinants are same, the value will be same, there will be 0. But we'll do it, that is the later part we'll learn in determinants. But here you can take in the first one, see omega plus omega square is what? It is going to be omega plus omega square is going to be minus 1. Just take minus both sides. Omega plus omega square will be what? Will be 1. What is omega cube? As I said, it is 1. Omega cube is 1. So just write 1 here. 1 minus 1 will be 0. So the first row becomes 0. Now coming here, 1 plus omega square, as I just said, it is going to be minus 1. But since it is already negative, it will be plus 1. So it will be minus 1 plus omega square. I can write it. It is going to be minus 1 minus minus plus omega. And now omega to the power 4. Omega to the power 4 can be written as omega cube and omega. Omega cube is 1, so it will be omega. This is 1, only omega will remain. So that is minus omega. Second row also becomes 0. Then we have third one, same thing. This is 1 plus omega square, you can write. Omega to the power 4 is 1, we just saw. And 1 plus omega square is what? It is going to be, this omega minus omega is going to be 0. So this is how the 0 comes. So you can do directly also, this way also, you can take negative outside also. All the ways are possible. Next one is A is this one, and you have to show that A square equals A. I hope you'll be able to do. You just have to multiply A twice and it will come as A, because then we have plenty of questions to do. A square equals I3. So when you do A dot A, it should come as identity. Identity is what? 1, 1, 1 in the diagonal. So 4 minus 1 minus 4. This is just the matrix multiplication, nothing else. So I'm just doing it for the sake of completion. I could have skipped it, but because we cannot skip all the questions, we just need to do in between some of the other questions so that you have a bit idea. So 4 into 4 is 16 minus 3. First row and first column I'm doing. Minus 4 is 12. First row and second column now. 4 minus 4 is going to be 0. Minus 4 minus 1 is plus 4. Then first row, third column. Minus 4 minus 4 minus 16. Minus 1 minus 4 is plus 4. Minus 4 and minus 3 is 12. Now second row, first column. 3 into 4, 12. 0 into 3 is 0. And minus 4 into 3 is minus 12. Then second row and second column. 3 into minus 1 is minus 3. 0 into 0, 0. Minus 4 into minus 1 is plus 4. So you get plus 4 here. Now it is becoming that identity matrix. If you see very closely, it is going that way ahead. Now the second row and third column, 4 is 12, negative 12. 0 minus 4 is 0. And minus 4 minus 3 is minus 12. Plus 12. Minus minus will be plus. Now third row, first column. 4 is 12. And minus 1 into 3 is minus 3. And this 3, 3, 9, negative 9. Then you have third row and second column. You can skip this question also, okay? I'm just doing it because it's matrix multiplication. So minus 3 plus 3 and 3, 4, 12. Minus 12. Minus 1 minus 4 is 4. Minus 3 is plus 9. Okay, now just see. This is 16 minus 15. 16 minus 15 is what? It is going to be 1. And we wanted and that the diagonal should come 1. This 4 minus 3 is 1. I'm taking the diagonals only. 4, 9 is 13. 13 minus 12 is 1. 4 minus 4, 0. This is also 0. 12 minus 12, 0. 12 minus 12, 0. 12 minus 12, 0. 3 minus 3, 0. Okay. This is the identity matrix of 3 by 3 order. 3 cross 3 matrix. So we have this question number 24. The first one and second one, they are exactly same. And how do we do it? Do we do both of them, or let us see one of them so that you have an idea how to solve this kind of question? You just have to do the matrix multiplication. The first is in front of you. I'm doing the second one. The type of first question we'll do in the later question. Okay, there are questions coming which are exactly like the 24 first part. So I'm just directly multiplying. 2, 1 is 2 minus 6, then minus 6 minus 6 plus 12. 5 is a 5, 5 is 7, 5, 7 is a 14, minus 14. 5 minus 3 is minus 15, 7 4 is 28. Okay, so we have to multiply it with what? So let me just write it. This is minus 4, this is minus 9, this is going to be 6, and this is going to be 13. 28 minus 15 is going to be 13. Now multiply it with this matrix, minus 4, 6, negative 9, and x. Okay. So row column, that is how we have to do it. So this multiplication is not there. Actually, it is equal to. So just x is equal to 13. That is the final answer. This is equal, not multiplication. I just need to correct myself. It is equal to. So this multiplication, 3 multiplications you have to do. Better you multiply the second matrix and third matrix and then multiply it with the first matrix. And you will directly get the x value from there because it is 0 eventually. So as I said, we have questions like this, and we just saw the 24 question first part. And as I said, we'll do this question because this is a quadratic equation. This is just a linear equation we got. But in this 25th, we will get a quadratic equation. Okay, let us do it. First row, and there are two x's. So 2 into x, 4 into 1 and 0. So 2x plus 4 will come. So x into 1, x, 4 into 0 is 0, 4 into 2, 8. 4 to the 8, okay? So I'll just change it. So x to 2x and 4 to the 8 and minus 4. Right? You have to multiply this by x, 4 and negative 1. 2x plus 4, and this is x plus this 2x plus 4. Now let us multiply it by x, 4 and 1. Okay. So I'll just change the middle one. Just wait a bit. Let us multiply 2x plus 4 into x is this one. And then we have 4, x plus 2. And then we have negative 2x plus 4, 2x minus 4 because it is negative. 2x square plus 4x and this value. Then we have minus 2x minus 4. It is minus 2x minus 4. So we get 2x square. 4, 4 and 2 is going to be 8 minus 2 is 6x. And this is, as I said, it's going to be 4. How it is going to be 4? 4 to the 8. That's what we need to change. 8 minus 4 is 4. So let us divide both sides by 2. You get x square plus 3x plus 2 equals 0. This can be written as x square plus 3x can be written as x plus 2x plus 2. Now take x common from here. X plus 1 you get. 2 common x plus 1 you get. So x plus 1 into x plus 2 is equal to 0. So x plus 1 equals 0. That gives x equals minus 1 and x equals minus 2. This is your final value. Okay, this question I hope you'll be able to do. 24th question first part, 25th question and 26th. They are absolutely exactly same. I hope you'll be able to do this. This is a and this is I. Then you have to prove a square minus a plus 2i is equal to 0. So are we going to do it? Because this type of questions are going to come. But since it is 2 by 2, we can do it quickly. So you know the idea how to solve this. A dot a is 3 minus 2, 4 minus 2. So let me write a again. 3, 4 minus 2 minus 2. This row, this column. So 3, 3 is 9, 4, 2 is 8 minus 8. This row, this column. So 3, 3 and 3 to 6 and minus is going to be 4 plus 4. Now second row, first column. 4 is 12 and minus 8. In second row, second column. 4 minus 4. Minus 4 is 8 and this will be plus 4. So you get 1 here. You get 4 minus 6 is negative 2. 12 minus 8 is 4. And 4 minus 8 is minus 4. Now let us multiply it with the... Okay, this is a square. Now subtract a from it because I am putting it in the equation. 3 minus 2, 4 and negative 2 plus twice of I. What is the identity matrix? This one. Multiply this with 2. 2, 2, 2, 0, 0, 2. Diagonal is 2. Okay. Let me change the pen now. Okay, directly we will write. So 1 minus 3 plus 2. Then 4, this second one. Minus 2, minus plus 2 and then 0. 4 minus 4 plus 0. Minus 4 plus 2 and plus, this is going to be minus 4 plus 4. Oh, minus 4 plus 2. Oh, sorry. Plus 2 and plus 2. Yes. So this is going to be 0, this is 0, this is 0, and this is 4 minus 4 is also 0. Okay. So this is the answer. Now this is the 28th question. We have to find out lambda here. So in order to find out the lambda, next question is also like this. It is not lambda, but just you have to find out a square and put values and just try to, fixate the equation or fulfill the equation. So there are questions coming like the 29th question and the different questions are there. So 28th will do because it is asking for lambda. A square is what? Okay, I'll just show you directly. A square is going to come like this. I hope you'll be able to do a dot a. So this is a square I'm writing directly. And this is equal to what? This is 5a. I'm multiplying this with 5. 5 to the 15. 5 minus 5. 5 to the 5. 5 to the 10. 5a is there, then plus lambda into I. Lambda into I, that is multiply lambda with this identity matrix. So all these diagonal value will be lambda actually. So lambda lambda 0 0. Now add matrix on the right hand side and equate it to the left hand side. So 15 plus lambda. So I don't have to compute anything else because 15 plus lambda is equal to 8 because they are equal matrix. Okay, just write it here. 8 minus 15, lambda will be equal to minus 7. Lambda is negative 7. This is the answer. So same thing, I'm just skipping it because you just have to put the values and show it to be 0. This again, same thing. Multiply a twice and then just write this value. Minus this is 1. This is the identity matrix. Identity matrix 2 by 2 is diagonal is 1. Okay. So this is a big exercise. A cube minus 4a square plus a. Now you can do in two ways. I'm just telling you, if you want to multiply it thrice, it's well and good. I'm just saying take a common. What do you get? A square minus 4a square, 4a plus 1. Oh, I hope you got the idea. So if you are able to show a square minus 4a plus 1 is 0, then of course this whole equation will be 0. You don't have to compute a cube. They see a cube already being done. I'm just suggesting that the other way to do this question is just take a common. When you take a common, only a square minus 4a plus 1 will be there. I'll just show you. This is a square. I'm writing a square here. A square I'm directly getting from the content already printed. And this is minus 4. I'm multiplying a with 4. This is 4 into a. Plus 1. 1 is what? Identity matrix. 1 is nothing. It is I. 1 0 0 1. Now you see, if this comes 0, then everything is 0. So this is 7 minus 8 plus 1. What is this? 7 minus 8 plus 1 is what? It is 12 minus 12 plus 0. What? 4 minus 1 plus 0. 4 minus, no. 4 minus, this is 4. So multiply 4. Why are we not writing 4? 4 minus 4 plus 0. 7 minus 8 plus 1. Okay. This is 0. This is 0. This is 0. Everything is coming 0. Even if it is multiplied by a, it doesn't matter. So rather than doing all these, just take a common. If this depends on, if this is of 5 marks, you have to do a cube minus 4a square plus 2. If it is 2 marks, just take a common. Okay, this they are trying to find out the roots. This also you will be able to find out. This CBSE 2004, put the values. So a is given, a cube minus 4a square plus a equals 0 or null matrix. Second one is a is this matrix and we have to find out a to the power 4. So the first part I am telling you, this is a cube minus 4a square plus a. Either you do a square and a into a cube, or what you can do is you can just take a common. That is a dot a you can do. So the best way to solve it, if this question is of 2 marks or 3 marks, just take a common. The inside will be a square minus 4a plus I. So you just have to find out a square. Now you don't have to go for a to the power 3. So when you compute this, it will come as 0. So this kind of question we have already done. So let us take the second part. So you have to find out a square minus 5a plus 7i equals 0. Use this to find a to the power 4. Okay. So this you have to prove that it is equal to 0, and using this we will compute a to the power 4 also. Okay. So let us see how we do it. We have to use this a square minus 5a plus 7i, that is a square equals 5a minus 7i, to find out a to the power 4. So let us see a square. This a square, since a is already given, in order to find a square, so this is 3, negative 1, 1 and 2. So this is also 3, negative 1, 1, 2. So row column, 3 is a 9 and 1 minus 1 is minus 1. 3 ones are 3 and 2 ones are 2. Negative 3 and negative 2, negative 1 and 2 is a 4. Okay. So what do you get? 9 minus 1 is 8. This is 5, this is negative 5, and 4 minus 1 is 3. So this is your a square. Okay. Now we have to put in here in this equation. It will come as 0. So let us put it these in the equation. This matrix minus 5 into a. So I am directly multiplying this matrix with 5 and putting it here. So 5 is a 15, 5, negative 5, and 5 is a 10. What about 7i? Identity matrix is what? 1, 0, 0, 1. The diagonal is 1 and multiplied by 7. So only the values which are 1 will become 7. Now let us do it directly. 8 minus 15 plus 7. 5 minus 5 plus 0. Then we have negative 5. Minus minus is 5. And then plus 0. 3 minus 10 plus 7. So 8 plus 7 is 15. 15 minus 15 is 0. So you get a 0. 5 minus 5 0. 5 minus 5 0. 3 plus 7 is 10. 10 minus 10 0. So what do you get? This we have already proved now. So now we'll find out a to the power 4. So a square is already with us. This equation, from this equation, a square I am taking 5a and 7i on the right hand side. So a square will be 5a minus 7i. Right? So let us do a cube. That is, multiply this with a matrix. Dot a. So a cube will be 5a square minus 7 into a. A into I is already a. Don't write I, because a into I, anything multiplied with identity matrix will be the same matrix. This is a cube. So on the right hand side, a square is there, and a square we already know. What is a square? A square we already know. A square is 5a minus 7i. A square is 5a minus 7i. So we will replace this a square with 5a minus 7i. Right? 5a minus 7i minus 7 into a. This will be 25a minus 7 is 35i minus 7a. So 25 minus 7a, what it will be? So this will be 18a minus 35i. So this is the first step for a to the power 4. A cube we have already got. Now we have to find out a to the power 4. So a cube will be multiplied by a again. So I am multiplying the right hand side also by, I am doing it here. A to the power 4 will be 18a into a, that is 18a square minus 35a into I will be a. So 18a square is what? 5a minus 7i. It will be 5a minus 7i. 18 into 5a minus 7i minus 35a. So this is 18 into 5, that is going to be 90, and 18 into 7 is 126 minus 35a. So when we do 90a minus 35a, what it will be? It will be 55a. 55a minus 126i. This is your a to the power 4, but still things are not over, because you have to replace. A is already given, no? 55 into a is what? 3, 1, negative 1, 2. And minus 126 into I. What is I? 1001. Multiply this by 126 and put in here. It will be 126, 0, 0, 126. Now multiply these two. 55 into 3 is what? 165. 55 is there, minus 55 here. 55 into 2 is 110. Now subtract these two. 126, 0, 0, 126. 165 minus 126 will be 39. First one will be 39. 55 minus 0 is 55. Minus 55, 0 is minus 55. 110 minus 126 is going to be minus 60. So what was that? This is a to the power 4. This is the final value. This is an important question I am telling you, NCERT. So here we have to, we have already done a question like this, the k's or the lambdas. Okay. So let us do it. A square equals ka minus 2i2. A square is 3, 4 minus 2 minus 2. So I am not doing a squared because I am taking directly from here. I am pretty sure that you will be able to do it. A dot a you have to find out. And the final is I am writing this is a square equals k into a. So multiply everything by k. So it will be 3k, 4k, minus 2k, minus 2k. So I'm just multiplying a scalar multiplication of this with this matrix. 3k, 4k, minus 2k and minus 2k. Minus twice into I2. I2 is 2 by 2 identity matrix. So 1, 0, 0, 1. So just write 2 inside because 2 is a scalar multiple. Now I'm taking the right hand side value on the left hand side. This is 1 minus 2, 4 minus 4 already. So I'm adding it with 2, 0, 0, 2. And on the right hand side, it is going to be 3k. I'll write all the value, but we don't need all of these. We need just one of them. So now just take this 2 plus 1. I'm just taking one of them. 2 plus 1 is 3k. This one. You have to do all of these, okay? I'm just telling you k will be equal to 1. Same thing here. CBSE 2005. So I hope you'll be able to do. Just multiply a twice. A square will be there. Multiply it by a, 8. And then multiply it by k, identity. 1, 0, 0, 1. So k will be equal to 7. So I am just doing it quickly because this exercise has a lot of questions. The multiple of them are equivalent, similar. Coming to this a, this is a kind of same question, but here is a twist, because what is the twist? Only the expression which is given. CBSE 2005. This is fx is given as x squared minus 2x minus 3. And we need to find out fa. Fx is this. Fa will be, just replace wherever you find x, just replace it by a. It will be a squared minus 2a minus 3. So just a dot a. So I'm not doing it. I'm just telling you what is the value. A square I'm using directly. I hope you'll be able to do it. It will be 5, 4, 4, 5. And minus twice of this. So multiply this with 2. So multiply this by 2. 2, 4, 4, 2. Okay. Then minus 3. 3 into I it has to be. It will always be identity matrix. So it will be 3, 3 on the diagonal. So 3, 0, 0, 3. Now let us compute. 5. Let me show you here. Take a different color. 5 minus 2 minus 3. And that is actually 0. 4 minus 4 minus 0. That is also 0. 4 minus 4 minus 0. That is also 0. And 5 minus 2 minus 3. That is also 0. This is fa equals 0. And that is what needs to be found out. We have showed it. Fa equals 0 here. Now this is a equals this, I is this. Find lambda and mu so that a square equals lambda a plus mu I. This a cube minus 4a square plus a equals 0. Okay. So the first one I am doing, a square plus lambda is equal to lambda a plus mu I. So a square, I hope you'll be able to do a dot a, just multiply this metric with the same metric. And a dot a I am directly writing. This is going to be 7, 12, 4, 7. Remember, this is a square. I have not done it. I have just taken it from here. A square. So this is a square. This is equal to lambda into a. So take a multiplied by lambda. Lambda is the scalar multiple. So now it will be all 2k, 2 lambda, 3 lambda, 1 lambda means lambda and 2 lambda. Now add it with mu I. Multiply this with mu. It will be mu 0, 0, mu. Okay. So let us add 2 lambda plus mu. 3 lambda plus 0 is 3 lambda. Lambda plus 0 is lambda. 2 lambda plus mu is 2 lambda plus mu. So on the left hand side you have 7, 12, 4 and 7. On the right hand side you have this one. So lambda you don't have to worry because lambda is directly being seen. This is already equal to 4. Lambda is already 4. Okay. Now put in any of the equation. You can take any of the equation. Let us take this one. 2 lambda plus mu equals 7. This is 7. Lambda is already 4. So 2 into 4, that is 8 plus mu is 7. Mu is 7 minus 8, that is negative 1. Okay. Now the second part, as I already told you, you can do it if this question is of 5 marks. But if it is of just 2 marks or 3 marks, you can just take a common, a square minus 4a plus I equals 0, and definitely this is going to be 0. Find the value of x for which the matrix product is an identity matrix. So we'll do the matrix multiplication and we'll equate it with the identity matrix. So I'll do it directly here, one by one. This row, first row with 3 columns, second row with 3 columns, third row with 3 columns. So first row, 2 into minus x is minus 2x, 0 into 0, leave it. 7 into x, write it, 7x. 2 into 14x, now this 207 will be with the second column, 28x. Then 0 into 1, 0, 7 into minus 4x, 7 4 28, minus 28x. The first row, third column, 2 into 7 is 14x, 0 into 0 is 0, 7 into 2, that is minus 14x. Now second row with first column. Now see how to reduce the calculation. First and third is already 0. And this row will always be multiplied with the middle one, will always be multiplied with the middle one. So just take the middle row of the second matrix and put in here. I hope you got the idea. When I take 0, 1, 0, 1, 0 multiplication with every one of these on the right hand side, means the column wise, 0, 1, 0 will remain. Now 1 into minus x, third row with the first column, minus x, and 0 will be 0 and plus x. Then third row with second column, 14x, minus 2 and minus 4x. Then last row with the last column, 7 to 7x, minus 2 into minus 2, leave it. 1 into minus 2x is minus 2x. Okay. So this is equal to identity matrix. I'll just write the identity matrix. This space is less. So we'll compute the left hand side and just equate it with the right hand side. That is the identity matrix. Let me compute it here. So this 7x minus 2x is going to be 5x. Let me change the color. 7x minus 2x is 5x. This is going to be 0. 14x minus 14x is 0. 0, 1, 0. This is also 0. 14 minus the last one is 5x. 14 minus 6x. That is going to be 14 plus minus 4 is 10x. 10x minus 2. That is going to be 10x minus 2. Now this is equivalent to this is equal to the identity matrix. Identity matrix, because we have to write 3 by 3 matrix, and the column values all will be 1. 1 0 0 0 1 0 0 0 1. Okay, 5x is equal to 1. Just equate it. X will be equal to 1 by 5. So all this you have to put a lot of effort, but in the last you see just 1 will be equated and x will be 1 by 5. 10x minus 2 is also 0, so 10x will be 2. X will be equal to 2 by 10. That is going to be 1 by 5. Solve the matrix equation. This is NCERT. So these all type we have already done. You just have to multiply and equate it to the null matrix, that is 0, and that x will come. This is NCERT and very important. But this type of question we have already done. So we'll try to take a question of this in the upcoming question. I will definitely do it. So this is already we have done, so I'm skipping it. This is x square minus 2a. So this a is there. How to do this? This is fx equals x square minus 2x. So if you take x as a, fa will be equal to a square minus 2a. So you have to compute this. A square is this whole square, and just multiply these two matrices, and a square will come, and minus twice of this a. So I'm just writing a square, directly writing a square. I hope you'll be able to do it. A square, I'm directly writing the value. A square is 496 20 29 8 8 16 9. Minus twice of a, multiply this matrix with 2 and write it here. Minus 2, I multiply every element by 2. So 0, 2, 4, and 4 2s are 8, 10, 0, and 0, 4, and 6. I multiplied everything with 2. Now see, just subtract it. 4 minus 0 is 4, 9 minus 2 is 7, 6 minus 4 is 2, 20 minus 8 is 12, 29 minus 10 is 19, 8 minus 0 is 8, 8 minus 0 is 8, 16 minus 4 is 12, and 9 minus 6 is 3. This is your final answer. fx equals x cube plus 4x square minus x. fa is this. Again, same thing. In place of x, just replace it by a. So let me show it here. It will take a lot of time to do it. So this is fx equals x cube plus 4x square minus x. Replace x with a, so it will be a cube minus 4a square minus a. So now you have to put a square, a cube and a. You can reduce your effort by taking a common, but ultimately you have to multiply a again. A square minus 4a plus I. So this computation become easy, but if you want to do it, you can do it. Otherwise, you have to follow the proper procedure. So let me show it to you here only. See, a is there, a square, this value will come. Then you multiply this again with the same matrix. A cube will come. A square and a cube we have got. So a cube you will write directly, but multiply a square by 4. That is value a square by 4. And then subtract it with the a. This value will come. This is a equals this matrix. Then show that a is a root of the polynomial given by this expression. That means what does it mean? Solution root. That is, a should satisfy this expression. This is an NCERT question. So the root means if you have fx equals the equation being given x cube minus 6x square plus 7x plus 2. It's a cubic equation. You can call it as a general polynomial equation. So if you put a in place of x, it will be a cube minus 6a square plus 7a plus 2 into I. I is the identity matrix. This is equal to 0. Then only a is the root of this expression. I hope you got the idea. So what you have to do is simply, because it will take a lot of time to do it, I'll just show you here. A you already have. A dot a, multiply these two. Then again multiply a, you will get a cube. So this a square and a cube you have to compute. You will have to take a square and a cube and put it in this equation along with the identity. That is a 3 by 3 identity matrix. This side, twice of this identity matrix. And when you put in here all these values, you will get it as 0. You will get a null matrix here. Null matrix. And that will be the root. That means. So a is this, and we have to prove. So this already we have done this kind of question. Just put a square and I here, and then it will be 0. Same case here, same thing. So since we have 4 zeros, it will be easier to do it. Okay. Without using the concept of inverse of a matrix, find the matrix this x, y, z, u such that. Remember, this type of question are coming later also. So we'll do this properly. So we have to multiply these two matrices and equate with the matrix on the right hand side. Okay. So there are certain methods. First, the multiplication has to be done. So I'm multiplying it. So multiplying this 5, negative 7, minus 2, 3 with this one, x, y, z and u. This row with this column. So 5x and minus 7z, or we can write minus 5x minus 7z also. Now 5 into y minus 7 into u. We can write minus here. Now second row with the first column, negative 2x plus 3z. Now this one also, minus 2y plus 3y. 3u. Now this is equal to, that in right hand side we have negative 16, negative 6, 7 and 2. Now let us equate. 5x minus 7z is equal to minus 16, first equation. Then we have 5y minus 7u is equal to minus 6, second equation. Then you have minus 2x plus 3z, minus 2x plus 3z, and this is equal to 7. The final equation, 3u minus 2y is equal to 2. Now this x and z, there are two equations having x and z, and there are two equations with y and u. So simultaneous equation we have, so we are able to solve it. So 5x minus 7z equals minus 16. This is one of the equation. Let me write it here. And we just need to find out one more equation, which is here, minus 2x plus 3z equals 7. I am writing the third equation. So how you can do? You can either multiply both equation by a certain number so that one of the part becomes equal, and then you can add or subtract. Or what you can do is you can, for example, this equation, second equation, I am trying to find out z. So 3z will be equal to 7 plus 2x, that is 2x plus 7. And z will be equal to 7 plus 2x by 3. So put it here. 5 into x minus 7 into z is 2x plus 7 by 3. And this is equal to minus 16. So just multiply inside 7 into 2x plus 7. I hope you'll be able to do all this, okay? I'm just doing it for the sake of completion. 14x plus 49. And this is divided by 3. Okay. Cross 5x, 15x minus 14x minus 49. And 3 I am taking on the right hand side. 3 into minus 16. That is going to be minus 48. So 15x minus 14x is x. And 49 we are taking on the right hand side. So 49 minus 48 is equal to 1. So x is equal to 1. So once you get x equals to 1, what do you get? Z equals to 7 plus 2 by 3. That is 9 by 3. So z is equal to 3. Right? Now coming to the other two equations. So we have 5y minus 7u equals minus 6. And from here 3u equals z plus 2y. So this u is z plus 2y by 3. Let us put in here. 5y minus 7 into 2y plus 2 by 3. 2y plus this by 3. Okay. So this is 2 plus 2y by 3. Now let us solve it. I'm directly writing the value of y here. So this, as I said, z was 3, x was 1, y is equal to minus 4. So x1 is there. As I said, 5 into 1 minus 7z equals minus 16. 7z equals z equals 3 was there. So here also y equals minus 4. Now put it in this equation or this equation. So what do you get? This is 2y plus 2. From here, this is 3u minus 2y equals 2. So when you put y equals minus 4, you will get u as minus 2. So we got all the values here. 4 values we need to find out. So u minus 2, y minus 4, z3 and x1. So let me show you here how this all value have come. If you ever want to do it in your copy pen use in the homework, for example. Find the matrix A such that this one and this one. So this is kind of the same question we have done just now. Okay. We'll take any one of these. Let us take the second part. So what we have to do is, we have to check. We need to know what kind of matrix A should be. For that, we need to know the dimension of the matrix. We cannot have a random matrix. See, the other two matrices will decide and will devise what dimension will be of that A matrix. For example, this one is 2 by 2, this is 2 by 3. So 2 by 3 can come when the first is 2 and the last one is 3. So 2 cross 2 and 3. But since 2 cross 2 it is there, so the next one has to be 2 cross 3. So this is a 2 by 3 matrix we have to write. So it will be x, y, z and ABC. So similar questions are there. So let me do the second part. The second matrix part, the matrix is 2 by 3 and the right hand side is 2 by 3. How this 2 by 3 can come? When the A matrix has to be 2 by 2. That is, the row and the column value of the first matrix has to be equal to the row value of the second matrix. And since 2 cross 3 will only come when we have 2 and 3 as the first and fourth value. So I am writing this as W, X, Y, Z. We are multiplying it with 1, 2, 3 and 4, 5, 6. And this is equal to what? This one, minus 7. So let us multiply first. I am multiplying these two matrices, Wx and 1, 4. So W into 1 plus 4 into X. So 4X. Then W into 2, 2W plus 5X. Then 3 into W plus 6X. 6x. Okay. Now second row with all the three columns. So you get y plus 4z. Then you have 2y plus 5z. Then we have 3y plus 6z. Right? Now this one which we have got has to be equated with the values on the right hand side. So you have to see which all equations are equivalent or having the same variable. For example, this w plus 4x, all the three equations in the first row are similar, means they are w and x. So let me just write w plus 4x, and this is equivalent to what? Minus 7. This is your first equation. Second one is 2w plus 5x. This is equal to negative 8. Third one, 3w plus 6x is equal to minus 9. Right? So now you can take any of the two equations and try solving it. Any two equations you can take. So 3w plus 6 plus 9x equals minus 15. I am adding first and second equation. Now subtract these two. Means the addition of first two and the third one. So when you subtract this, what do you get? 6x minus 9x is minus 3x. And minus 9 minus 15, that is plus 15. 15 minus 9 is 6. So x will be equal to minus 2. X is minus 2. Now put in any of these equation. W plus 4 into 2, that is negative 8, equals minus 7. W equals 8 minus 7, that is going to be 1. W is 8 minus 7, that is 1. Now the third one, means the second part. Coming to these three, now what you can do is, see in the first part, what we have done, there are three equations which are similar. So we added two of the equation and subtracted with the third. You can just choose any of the two equation and do it by yourself, means the way you want. This is one of the way. Right? So I'm just rechecking it, and this is actually, so this is what you get. Now coming to the second row, that is 3y plus 6z, and this is equal to 6. That is I'm writing the third equation. This is equal to 6. This third one, 6. Then we have y plus 2z and 2y plus 5z. So this is also has to be equated. Y plus 4z is equal to 2. And 2y plus 5z is equal to 4. So add these two equations. 3y plus 9z equals 6. Now write it here. 3y plus 9z equals 6. Now subtract these two. When you subtract these two, what do you get? Because what we see here is when you subtract, z is coming as 0. So you need to just recheck. So this, I think that we are onto the right track. Subtract this. When you solve this, 9z minus 6z is equal to 3, because 3y gets cancelled. And this is 660. So z is 0. Now put in any of the equation. So you get y equals what? Z is 0. 4 into 0 is y plus 4z equal to. This y is equal to 2. Find a 2x2 matrix A such that A into this matrix is equal to 6 into I2. So what you have to do is, see, A into 1 minus 2, 1, 4 is equal to 6 into I2. That is 2 by 2 identity matrix. 1, 1, 0, 0 here. What is A matrix? When we do this, because it is a scalar multiplication with 6. This is 2 by 2 and the right hand side is also 2 by 2. So the A matrix has to be 2 by 2. Because only this 2 by 2 can come when the first and the fourth value are 2 and 2. W, X, Y, Z. We multiply this with 1, negative 2, 1, 4, and this is equal to multiply by 6, 6, 0, 0, 6. So this kind of question we have already done. 2 or 3 questions we have done. I hope you'll be able to do it. Okay. What you have to do is, let me just give you a hint. W into 1 plus X into 1, that is equal to 6. And W into minus 2, that is minus 2W. And X into 4, so 4X. This is equal to this is 0. So second one is 0. Then we have Y into 6. 6Y plus Z is going to be 0. This is minus 2Y plus 4Z equals 6. Right? So now what you can do here, I'm multiplying first equation by 2, 2, this becomes 12. Okay, just add these two equations, this gets cancelled. So this is 4x plus 2x is 6x, 6x equals 12, x is equal to 2. So x is 2, w plus x was 6, so x has to be 4. I'm putting it here, w plus 2 equals 6, so w will be equal to 6 minus 2, that is going to be 4. Now y plus z equals 0, so multiply this again by 2, 2 is 0. Now add these two equations. So this is 0, 4z plus 2z is 6z equals 6, z is equal to 1. Now put it here, y plus z equals 0. Z is 1, so y will be equal to, because z is equal to minus y, and y is equal to minus z. Z is 1, so y will be equal to minus 1. So these are all the values. So how you need to write the matrix? You cannot just leave it here. You have to finally write the matrix, that is all the values. W, x, y, z. W was 4, x was 2, z was 1, and y was minus 1. So this is going to be a final matrix. If A is this, A to the power 16 is what? A to the power 16, it seems to be pretty difficult. But when you see what is A into A, just do A into A, then you will see that, oh, everything is 0. So finally, A is 0 will come, null matrix will come. A is what? 0, 0, 4, 0. Now you just see the A square. 0, 0, 4, 0. Multiply this again. 0, 0, this is 0, 4, 0. So just multiply these two, what do you get? See, this is row column, 0 into 0 is 0, plus 4 into 0 is 0, so 0. 0 and this row, this column, so you get 0. Now 4 into 0 plus 4 into 0, that is again 0. Then 4 into 0 plus 0 into 0, again 0. Now you take A square and multiply A square with A square, you get A to the power 4, that is going to be 0. Then A to the 4, multiply again with A to the power 4, that is going to be A to the power 8, that is going to be 0. A to the power 8 with A to the power 8, A to the power 16, that is going to be 0. What I am trying to suggest here is A square dot A square is null matrix into null matrix, that is going to be null matrix. A4 is null matrix. When you take A4 and multiply it with A4, because both are null matrix, what do you get? A to the power 8, that is null matrix. When you multiply A to the power 8 and A to the power 8, the power gets added, that is null matrix into null matrix. What do you get? You get n to the power this 16, means A to the power 16, that is going to be 0. If A is this matrix, prove that A raised n is this matrix for all positive integers n. How do we do this? We will do this and the later 4-5 questions with the principle of mathematical induction. So you need to know mathematical induction before even solving or attempting this question. But I'll give you a hint. I'll give you the steps. How are we going to do this? See, this A raised n is equal to this 1 n 0 1 for all positive integers n. So this is a matrix. So if the first step should be, if it is equal to or it is true for n is equal to 1, then we proceed. So what is A to the power 1? In place of n, I am putting 1. 1, 1, 0, 1. See, this is already given. A is 1, 1, 0, 1. And when we placed n as 1, we actually got what is being given. The second one is when, see, we have to assume for n equals k. And if we can prove that if it is true for n equals k, it is also for n equals k plus 1, it is true, then we say it will be true for k, k plus 1, k plus 2, and for all the k's, that is all the n's. So we assume the first step was n equals 1, it should be proven. Then n equals k, we assume it to be true. So we assume it to be. So what we get, we assume that for n equals k, it is given m here in the solution, but you can always use k. So what is a to the power k? This is equal to, in place of n, just put k. 1k, 0, 1. Okay? And if this n is equal to k, if it is true, and if it is equal to, or it is true for n equals k plus 1, given that n is equal to k, it is true. Then it is true for every n. So what is a to the power k plus 1? How can we write a to the power k plus 1? If I write a to the power m plus n, that is simply meaning a to the power m into a to the power n. So a to the power k plus 1 can be written as a to the power k and a. What is a to the power k? We just wrote it. We also said that it is true. A to the power a raised k is what? 1k 0 1. And what is a? It is already given. It's given already 1 1 0 1 1 1 0 1. Now when we multiply this, and if it comes to true for k plus 1, if I do it for k plus 1, what should come? 1 k plus 1 0 and 1. That is k should be k plus 1. If it is true for k plus 1, then it is true for every other k or every other n. So let us multiply these two matrices, and the matrices should come as that matrix 1k plus 1 0 1. So let us multiply this row with this column. 1 into 1 is 1, k into 0 is 0, so leave it. 1 into 0, 1 and k and 1 1, 1 into 1 and k into 1, that is this one. 0 into 1 is 0 and 1 into 0 is 0, so 0 plus 0 is 0. 0 into 1 is 0 and 1 into 0 is 1 into 1 is 1, 0 plus 1. So what do you get? Finally what we get? Let me just change the color now. We get 1 plus k, or I can write it as k plus 1, 0 and 1. So what is this? As I told you, it should come as like this, and for n equals what is true, for n equals k assumed that it is true, and it is true for n equal k plus 1 assumed n equals k. So by principle of mathematical induction, this is true for every positive integers n. Now this one is also of this type. So if you see the question in the book, what is the question, we need to understand that first. Whether it is b into a raised n minus 1 by a minus 1, or whether it is, which one, you just see. So we'll do it using the principle of mathematical induction. First step, we need to prove it that this is true for n equals 1. When we put n equals 1, this has to be true. Okay, so this is a raised 1, a raised n is a raised 1, n equals 1. This will be a raised 1, 0, b into a raised n minus 1. Please remember what you see in the question. It seems like it is a raised n minus 1. That is a raised to the power n minus 1. But it is not like that. It is a raised to the power n minus 1 divided by a minus 1. So you will just see. I'll just take care of what exactly is given, and then I'll show you that it is a raised to the power 1 minus 1, and since a raised to the power 1 is a, so a minus 1 divided by a minus 1 gets cancelled. You are going to essentially get b. So a, b, 0, 1. This is what you get, right? So let us see here. So this is like this: a to the power n, b, a to the power n minus 1 by a minus 1. This is like this. And then we have 0 1. Okay, so this is a raised n minus 1, so a minus 1 by a minus 1. So this gets cancelled, you get b, a minus 1 by a minus 1, it gets cancelled, you get b. Okay, final is this like this. This is b, a, b, 0 1. So this is true for n equals 1, and this is the first step in any mathematical induction. It should be true for n equals 1. Now let us assume, as we did in the previous question, let us assume this is true for n equals k. Okay, so this is a raised k, and we assume it to be true. So this is a raised k, b into a raised k minus 1 divided by a minus 1 and 0 1. So we assume that this is true, and using this, if we can prove that this is true for n equals k plus 1, this will be true for every positive integer n. Okay, so the final answer will be like this. Let me show you the final answer. What should come? It should come as k should be k plus 1, a raised k plus 1, then b dot a raised k plus 1 minus 1 divided by a minus 1, 0 and 1. So this is what we should get when we put n equals k plus 1. So a raised k plus 1 can be written as a raised k, this a raised k dot a. Okay, so We'll try to get that what I have written in the purple in the above part. So this is a to the power k into a. So as I said, x to the power a plus b is nothing but x to the power a into x to the power b. So a raised k dot a raised 1. That is this a raised k. Let me write it here. A k b a k minus 1 by a minus 1 and 0 1. So this has to be multiplied with this a b and 0 1. This multiplication has to be done. Okay. So let us multiply it properly. So this a raised k into a raised k into a raised 1 is a raised k plus 1. This row and this column. Multiplying this b, whatever is with multiplied with b 0 will be 0. Now this row again with this column, so a raised k into b plus this same thing because it is multiplied by 1. So just write it here, a to the power k minus 1 divided by a minus 1. Now second row with the first column, 0 into a is 0, a 1 into 0 is 0. And b into 0 is 0 and 1 into 1 is 1. Okay. So three things we got. A raised k plus 1 we got, 0 we got, 1 we got. This only the thing which we see, it should come as b a raised k plus 1 minus 1 by a minus 1. This has to come like this. So let us see this. So I am doing it here. The base will be, I am taking the LCM a minus 1. So this will be multiplied a minus a to the power k b into a minus 1 plus b into a raised k minus 1. So this will be, see, I am writing it here, a k b into a minus a raised k dot b plus b a raised k minus b divided by, so b a to the power k and a raised k dot b, this gets cancelled. So this is a raised k b a minus b divided by a minus 1. So what do you get? B. Take b common. What do you get? A raised k into a. And we already know a raised k dot a raised to the power 1 is what? A raised k plus 1 minus 1 by a minus 1. And what was this? This was exactly this one. Okay. So when we did a to the a raised k plus 1, we got this. So when it is true for n equals 1, we prove it for a raised k plus 1. A is given cos theta plus I sin theta cos theta. Then prove by mathematical induction that this a raised n is this for all n belongs to capital N. Right? Okay. So this type of question can come in your exam. This will weight around 5 marks. So a raised n, let us prove it for n equals 1. Because n equals 1 has to be true. So I'm showing it to you here. Just replace n by 1. That is a raised n. I'm replacing n by 1. So a raised to the power 1. What do you get? Cos into n theta, that is cos theta. N I'm putting as 1. Then I sin 1. So I sin theta. Then we have I sin theta. Then cos theta. So for n equals 1, you got the correct one. Okay. So for n equals 1, you got the correct option. Very good. Now let us assume that this is true for n equals k. For n equals k or n equals m, whichever you want to take, a raised k will be what? So just replace n by k here. This is what we are assuming that it is true. For k it is true. And with this base, we will try to prove that it is true for k plus 1. So cos k theta, I sin k theta, I sin k theta, cos k theta. Just replace n by k. So we are assuming that for any k, that is n equals k, this is true. Now we will check it for n equals k plus 1. So a raised k plus 1. Okay. A raised k plus 1 is a raised to the power k and a raised to the power 1. A raised k we already given here and a is on the top, the first one. So a raised k. So we are multiplying these two actually. Essentially we are multiplying these two. So I am multiplying these two. Cos theta, I sin theta That is a raised k we have already written. A raised power 1 I am writing. Cos theta, I sin theta, and cos theta. Okay, so we need to now multiply these two matrices, and final answer should give you, wherever k is there, it should give k plus 1. Okay, so I am multiplying it now. See, what should come? As I said, every k should become k plus 1. Then we say that if it is true for n equals k, it should be true for n equals k plus 1. Let us see. So this row with this column, 1 by 1. So I am multiplying cos k theta with cos theta. Cos k theta into cos theta. Plus, now I sin k theta with I sin theta. Now you see, I into I is I square. Because this is complex, so I square will be equal to -1, -1. So I am replacing this plus with negative sign. Wherever I square will come, we'll write this like this. Sin k theta into sin theta, it will be sin k theta into sin theta. This is the first one. Now this row with this column, cos k theta into I sin theta, cos k theta into I sin theta. So just write it here, cos k theta into I sin theta, plus I sin k theta into cos theta. So this is the second entry. Now we go to the second row. You can take the I common. So I'm taking I common. I'm removing this I, and I'm just making my work easier because I would then have to write all these matrix again. So I'm just taking I common here. Now coming to the second row, multiply with the first column. So I'm taking I outside. I outside. I know I will come outside. Sin k theta into cos theta. Sin k theta into cos theta. And cos k theta into I sin theta. So I is taken already common. So cos k theta into sin theta. This is the first entry. The second one. Now the second row with the second column. I square will be I square. This I into sin k theta into I into sin theta. I square will minus. So sin k theta into sin theta you can directly write. Then cos k theta and cos theta plus cos k theta into cos theta. Right. Now you see very carefully. We have certain formula, certain identity, certain relationship, trigonometric relationship that we are going to use. Cos A cos B minus sin A sin B. What is cos A cos B minus sin A sin B? It's cos A plus B. Cos A cos B. Let me write it here. Cos A cos B minus A sin B will eventually give you cos A plus B. What is A? K theta. What is B? Theta. So cos K theta plus theta. See, cos K theta plus theta. Okay. Now I am taking common. Cos A sin B plus sin A cos B. So it will be sin A plus B sin K theta plus theta. Okay. Now this one, again same thing will come. I sin A cos B plus cos A sin B. That is I sin K theta plus theta. This is minus. So cos, you can write it as cos K theta cos theta minus sin K theta sin theta. And it is essentially equal to cos A plus B, that is cos K theta plus theta. Now, wherever you have K theta plus theta, if you take theta common, you get a K plus 1. You can always write it as K plus 1 theta. So I told you already in the earlier part that wherever K is there, if you can get K plus 1, then it is true for K plus 1. So let us see here. This will be cos, I'm writing K plus 1 theta in place of K theta plus theta. Plus this is I sin K plus 1 theta. Then we have I sin K plus 1 theta cos K plus 1 theta. So is it A raised K plus 1? Yes, it is. It's A raised K plus 1. And that's what we wanted. So we proved it using the mathematical induction. N equals 1, it is true. For K we assumed, and K plus 1 it already came. Now if A is this matrix A to the power n, we have to prove that this is this matrix for all n which is belonging to the capital N, which is the natural number. So wherever alpha is there, you see there is n alpha. So we'll do it using the mathematical induction. We already seen some questions like this. So the first thing which we do in the mathematical induction is we prove that it is true for n equals 1. That is, in the place of n, put 1. That is, you want to have a, you want to get a. So I am taking a to the power of n, putting n as 1. So wherever n is there, put 1. So you get cos alpha, a sine into 1 into alpha, a root 2 sine n into, that is 1 into alpha, then minus root 2 sine into 1 into alpha, that is sine alpha, and cos n is 1, so cos alpha minus sine n is 1, sine alpha. Okay, are these two equal? A and a to the power 1? Yes, absolutely equal. That is the first step in the mathematical induction is done. Now coming to the second step. Here we assume that this is true for all n equals k. We assume it to be true for all n equal to k. Okay. So just put k as n as k. So cos k alpha, wherever n is there, put k. Cos k alpha plus sin k alpha, then minus root 2 sin k alpha. Then we have root 2 sin k alpha. And we are replacing it by k. So cos, again, in place of n, just put k alpha. So cos k alpha minus sin k alpha. Okay. Now, the next step is, we have assumed that this is true for any n equals k. We have assumed it. This is true. Now we come for, we want to prove it that if it is a to the power k plus 1 holds. If a to the power k plus 1 holds, it will hold for any value of n. Okay. So what do we do? How can we write this a to the power k plus 1, a to the power k into a to the power 1, a raised k into a raised 1. That is, essentially we have to multiply the second with 1, the second with first. So we are multiplying these two now. I hope I am writing this a raised 1 here, the red one, and I am multiplying it. So I am writing directly. So this is the multiplication of a to the power k, a raised k into a raised 1. So first row of the a raised k and first column of a1 I am writing. Cos k alpha plus sin k alpha multiplied by cos alpha plus sin alpha. So first row with first column. Cos alpha plus sin alpha. This is first multiplication plus this second value with the second value of the column. So root 2 sin k alpha into minus root 2 sin alpha. So I am directly writing because root 2 and root 2 is 2. If you multiply root 2 and root 2, that will be 2. And negative, just put a negative sign here. So 2 sin alpha sin k alpha. Okay. Now second one I am writing just below it because there is not enough space. Now the first row with the second column. That is, I am multiplying cos k alpha plus sin k alpha with root 2 sin alpha. So root 2 sin alpha into cos k alpha plus sin k alpha. You can always use k as m also. Plus, now root 2 sin k alpha multiplied by cos alpha minus sin alpha. Root 2 sin k alpha multiplied by cos alpha minus sin alpha. That is, the second value of the first row of the first matrix multiplied by the second value of the second column. So cos alpha minus sin alpha. Now we are taking the second row of the a raised k and first column of a raised 1. So minus 2 sin k alpha multiplied by cos alpha plus sin alpha. Plus. Now cos k alpha minus sin k alpha need to be multiplied with minus root 2 sin alpha. So I am purposefully placing a sign negative here, root 2 here, and sin alpha will be multiplied by cos k alpha minus sin k alpha. Right? Now this row, see, this is already done. Okay. Please remember, second row with the first column we have multiplied. And now second one. So minus is root 2 is 2, sin alpha, sin k alpha. Second row, this minus 2, root 2 is 2, sin k alpha, sin alpha. And then the second one is cos k alpha minus sin k alpha into cos alpha minus sin alpha. cos alpha minus sin alpha. Okay. Now we need to just multiply and use the trigonometric identity, relation, and equality and put the value here. First one I am writing. We are multiplying each and every element, and then I'll try to show you few of these entries and what it comes. Okay. So most of the thing you know about this, you need to know the what is cos A cos B plus cos A sin A sin B, like this, cos A sin B minus sin A cos B. All these you must know before actually attempting this question. Now multiplying now, see here, cos K alpha into cos alpha, and then cos K alpha into sin alpha, then sin K alpha and cos alpha, and then sin K alpha into sin alpha, sin K alpha into sin alpha, minus 2 sin alpha sin K alpha. But you see here, sin K alpha and sin alpha is already there. So sin K alpha sin alpha minus 2 sin alpha sin K alpha is equal to minus of sin alpha sin K alpha. These two we are taking and we are subtracting it. Let us subtract it. So what do we get? Sin alpha sin K alpha negative. Okay. So we need to rearrange it. It's so that we can use the formula here. So there can be some cos A plus B, there can be some sin A plus B kind of formula. Okay. So cos A cos B plus sin A sin B we have, because cos K alpha and cos alpha is there. Do we have sin K alpha? Yes, we have cos K alpha, cos alpha, and this one we are taking minus sin K alpha, sin alpha. So it is cos A cos B minus sin A sin B. Here we have, so cos K alpha sin alpha, that is cos A sin B plus sin A cos B formula. Okay. So what do we get? The first one is cos A minus B, A plus B, sorry. And the second one is sin A plus B. So this is sin A plus B, sin A alpha plus alpha. This one is cos A cos B minus sin A sin B is cos A plus B. Just write cos A alpha plus alpha. So this is just the first entry. This is the first entry, okay? We have to do it for all the 4 entries, and depending upon the formula and the expressions, we have to devise the k plus 1 wherever n is there. Okay, now let's do the second entry of the first row. So I'm just saying that if k alpha plus alpha can be written as k plus 1 alpha. Alpha you take common. So what do we need? Excuse me. K, what do we need? We need, wherever k is there, we need k plus 1 alpha. Wherever there is k, we need k plus 1. And we got it. See, k plus, the first entry of the matrix is cos k plus 1 alpha and sin k plus 1 alpha, that we got. And same thing you have to do for every other entry. Let us take the one more entry till we have enough space. So I am taking this one. So root 2 sin alpha. There is, what you can do is you can take root 2 common, because if you have root 2, you will not be able to use the expression and the equalities or the formula in what we have seen earlier in our trigonometry discussion. So what we will do here is we will take root 2 common here to make it easier. So just assume that root 2 is already there. Now multiplying the inside ones. So this we get sin alpha. Now multiply each and every element. Sin alpha cos k alpha, sin alpha cos k alpha, and sin alpha sin k alpha plus sin k alpha cos alpha, sin k alpha cos alpha, minus sin k alpha and sin alpha, Now you see these two are common, so just cancel it out. What do you get? This is cos A sin B plus sin A cos B. And what was that? It is actually sin A plus B. You can say sin A cos B plus cos A sin B. It is sin A plus B. So sin K alpha plus alpha, sin K plus 1 alpha. Root 2 is already there. So what do you get? root 2 sine n alpha, that is root 2 sine a alpha, we assume it to be true. Now we got root 2 sine k plus alpha. So the first one was this one. The second one entry is this one, and which we wanted. So the third and fourth entry, you need to recheck, and I hope you will be able to solve it. First and secondary, I already told you. It was cos and root 2, but this minus root 2, this one minus root 2 sine k plus 1 alpha, and cos m1 plus this k plus 1 alpha and minus sine k plus 1 alpha, you have to do by yourself. This is for your reference. So 2 I have done, 2 you have to do. Okay. I hope you have got the idea because I told you how to do it. Now A is this. Then use the principle of mathematical induction to show A raised n is this matrix. We'll use it. We use the concept of mathematical induction. The first one is this. If you put n as 1, what do you get? A raised 1. So in A raised n, just put n as 1. So 1, 1. I'm writing other ones 1, 1, 1. And then we have 0, 0, 1. Okay. N plus 1 by 2, 1, 1 plus 1 by 2, that is 2 by 2, that is 1. So what do you get? It is 1. So this one is exactly similar to A, and A is nothing but A raised to the power 1. Now the second step is, we assume that it is true for any k. You can also call it as m, but I am calling it as k. For any k it is true. That is 1, k plus 1 by 2, and this is 0, 1, k, 0, 0, 1. Right? Now the third step is that if assuming that it is true for A raised k, it must be true for A raised k plus 1. If we are able to show it for A raised k plus 1, then it is true for every integer n. A raised k plus 1, how do we write? A raised k into A raised 1. So wherever you see k here, the answer should be k plus 1. Everywhere k plus 1 should come. So now I'm writing A raised 1 because I'm multiplying A raised k with A raised 1. I'm multiplying these two. This is simple matrix multiplication. So multiply 1 into 1 is 1, k into 0 is 0, k plus 1 by 2 into 0 is 0. So only 1 will remain. Now the first row with the second column, 1 into 1 is 1, k into 1 is k, and this into 0 is 0. First row with third column. So we have 1, 1, 1, so all has to be added, 1 plus k plus k plus k plus 1 by 2. This needs to be added. Now second row with the first column, 0, 1, 0, 1, 0, 0, k into 0, 0, everything is 0. Now second row with the second column, 0, 1, 0, 0, 1, 1, 1, and k into 0 is 0. And now second row with the third column. So 0, 1, k has to be added because all ones are there in that column. So 1 plus k will be there. Now this row with this column, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, so only 0 will come. Again 0 into 1, 0, 0 into 1 and 1 into 0, so 0 will come. Now the third row with the last column, so 0 plus 1, that is going to be 1. Okay. Now you have already reached the step because I wanted k plus 1 and we wanted k plus 1. So k, this is k, we got k plus 1. This is k, we got k plus 1. So only this one, we need what? We need k plus, everywhere k plus 1 should be there. So we need k plus 1 and then k plus 1 plus 1, that is k plus 2 and divided by 2. This is what we get. If we solve this one and we get this one, we are already done. So let me solve this. 1 plus k into k plus 1 by 2. Now 1 plus k, you take common. 1 plus k by 2 will remain. So this is 1 plus k and this is 2 plus k by 2. So k plus 2 by 2. And what is this? This is what we wanted. Okay. This one is exactly similar to this one. So we have already proved that it is true for A raised k plus 1 if we assume that it is true for A raised k. This is the final answer, that this is true for every positive integer and for any k assumed to a plus 1. If BC are n-row square matrix and if A is equal to BC, BC equals CB, C square equals null matrix 0, then show that every n belongs to capital N, A raised n plus 1 is given by this expression. n row square matrix means if it is having n rows, it will also have n columns because it is a square matrix. So what is given in the question is this one. We'll use the mathematical induction here and try to resolve the issue so that we get, first let us start with n equals 1. Wherever you have n, put 1. So left hand side, if you put n as 1, it will be a 1 plus 1 a square, n is 1. Right hand side, b raise n is 1, and then b plus n will be 1, 1 plus 1 is 2, so b plus 2c. A square is b into b plus 2c. Let us see what is a square actually coming, because a square is nothing but a dot a. A is given b plus c, so we can multiply b plus c and b plus c because a into a. Multiply each and every element, b into b, then b into c, then c into b, then c into c. C square. This is b square. Now, BC plus CB is already given to be equal in the question. And C square is also given as 0. So BC and CB are equal. BC plus CB, CB can be written as BC. BC plus BC is 2BC. So you have B square plus 2BC. And C square is already 0. So just take C square as 0 because it is given in the question. So it is already given, so we can just take b common from here. In b square plus 2bc, I am taking b common. What do you get? b plus 2c. And this is exactly similar to right hand side of a square. See here. So for n equals 1, we have proved it. For n equals 1, it is true. Now the next step is we assume it to be true for n equals k. So n equals k. So wherever n is there, just put k. So a raise k plus 1, b raise k, and b plus k plus 1, c. We assume this to be true. And if it is true, we need to show that everywhere when k is k plus 1, it is also true. If it is k is true, k plus 1 is true, then it is true for any value which you choose. So we will try to do it for n equals k plus 1. Okay. So in place of n, I am writing k plus 1. So I am writing k plus 1. So a raise in place of k plus 1. So plus 1 is already there. So a raise k plus 2. So k plus 1 is k plus 1 plus 1 is k plus 2. So k plus 2 is there. Is equal to b raise. N is k plus 1. We are writing k plus 1. Then we inside have capital B plus n. I am writing k plus 1. So k plus 1 is k plus 2 into c. Right? Now, this a raise k plus 2 can be written as a raise k plus 1 into a raise 1, because if you add the power, it will be k plus 2 only. A raise k plus 1 is already there. A raise 1 is already there with us. How do we get a raise 1? When we put n as 0. If I put n as 0, I will get a raise 1. So right hand side also you have to put n equals 0. So b raise 0. And then we have b plus n is 0, so it will be 1 only, so c. So b into b plus c. b raised 0 is already 1. Anything raised to the power 0 is 1. So a is bc. A raised 1. Essentially what I am trying to suggest here is a raised power 1 we need to find out. In place of n, if you put n as 0, then we get a raised power 1. So right hand side also n has to be put 0. Essentially we get b plus c. So a raised k plus 1 I have already written. And a raised 1, I am writing it as b plus c. This I am writing again. B raised k. A raised k plus 1 is what? B raised k. And b plus k plus 1 into c. This is a raised k plus 1. And a raised 1 is, as I just suggested, it is b plus c. Just write b plus c. So we already come till here. Now we'll directly multiply it. B multiplied with b raised k plus 1, bk plus 1, k plus 1 plus the power is added, bk plus 2 will be there. This is k plus 1, b raised k, and b raised k into b into c or c into b. Because b, c, c, b are same, that is why I am writing interchangeably. Now coming to c, this is b raised k and c. And then we have this one, the last one, which is k plus 1, b raised k, and c into c is c square. k plus 1, b raised k, c into c is c square, but c square is already given 0. So you just leave this because it is 0. What do you get? bk plus 2. Now what do we want to have? We need a raised, let me tell you again, it is n should be kept as k plus 1. So we need a raised k plus 2. This has to be equal to b raised, in place of n, write k plus 1. Inside, just go there. B will remain like this, n will be k plus 1. So k plus 1 plus 1 is 2. And then c. This is what we wanted. Finally, whatever we do here, whichever arrangement we do, we need b, this above element which I just told you. B raised k plus 2, this is already 0. Now I'm taking b, this is b raised k dot b. So this is essentially equal to b raised k plus 1. Okay. So b raised k plus 1 and c we can take common. Why? Because bc and cb are same. So I'm just taking b, this c b k plus 1 or b k plus 1 cb I'm taking common. So k plus 1 remain here and 1 from here. So k plus 2 will be there. K plus 2. And now we'll take b raised k plus 1 common from all these two. So I'm taking b raised k plus 1 common. What is remaining here? Only b. This already we have taken b raised k plus 1. So only k plus 2 into c will remain. So what do we get? Remember, I told you a raised k plus 2 will be what? This is exactly similar to this one. So by principle of mathematical induction, it is proved. If A equals diag, that is diagonals of ABC, show that A raised n equals diagonal of A raised n, B raised n, C raised n for all positive integer n. So whenever we encounter this kind of question, we have to do it using the principle of mathematical induction. So how do we do this? We'll apply the method which we have already seen in previous questions. The first step is we need to prove it that for n equals 1, this is true. If we place n equals 1, it has to be equal to the thing which is given, which is A equals diag ABC. What is diag ABC? Let me write diag A n, B n, C n. This is A n, B n, C n only in the diagonal. Other values are going to be 0. So A raised 1 means n, replace n by 1. So what do you get? You get here, this all other values are 0. So this is A, B, C. Here 0, 0, 0, 0, 0 like this. So this is nothing but A raised 1. This is diagonal of A, B, C. So for n equals 1, this is proved. Now we assume the second step always in the principle of mathematical induction is we assume that this is true for all k, any k. And we need to prove it that if it is equal for k, okay for k, it is also true for k plus 1. So let me write A raised k. So wherever we have n, just replace it by k. You can replace it by m also, it depends on you. Normally in principle of mathematical induction, we use k. Now here, the third step is, if it is true for ak and if it is true for ak plus 1, then it is true for every other number. So ak plus 1, that is wherever you are getting this k, you need to get k plus 1. That is, it is true for k, that is k plus 1, and the k plus 2 like this. It will be true for every other number. So A raised k into A raised 1. A raised k plus 1 can be written like this. So A raised k is already given, means already we have written. Now I am writing A here, A raised 1. So I am writing this A0, 0, 0B0 and 0, 0, C. Okay. So now we have to multiply these. The first one is A raised k, second one is A. So wherever you are seeing k, if it comes out to be k plus 1, then it is true for A raised k plus 1 also. Okay. Let us multiply. You know how to do the matrix multiplication, first row, first column, first row, second column, first row, third column. Similarly, we do it with the second row and third row. Same thing. So A raised k and into A are the 0. Then second one also, all are 0 because A, third one also, A k 0 is 0, 0, 0 C. Now coming to the second row. 0, 0 and A is 0, B k 0, 0, 0, so 0. Now second row, second column, 0, 0, BK, B is BK into B. B raised K into B. Now 0 into 0 is 0 again. So what do you get? 0. The third one, third row and first column. 0, 0, 0, 0, C into 0 is 0. Now third row, second column. So 0, 0, 0, B in 0, C into 0, 0. And then we have the third row and the last column. So 0, 0, 0, 0, 0, 0, C into C, C raised K into C. So what is a raised k into a? It is a raised k plus 1. But how can we write this? See, a raised k plus 1. We can write b raised k and b raised 1 is b raised k plus 1. C raised k and c raised 1 is c raised k plus 1. So what is this? This is what we wanted. This is a raised k plus 1. Hence, from the principle of mathematical induction, it is proved for all positive integer n. A matrix X has a plus b rows and a plus 2 columns, while matrix Y has b plus 1 rows and a plus 3 columns. Both matrices xy and yx exist. Find a and b. Can you say xy and yx are of the same type? Are they equal? So first matrix. Now you need to know that the column of the first matrix has to be equal to the row of second matrix. That is, if this is the row and columns are I'm writing, a plus b is the rows and a plus 2 is the column of the first matrix, which is your X matrix. Now coming to the Y matrix, we have the row number as b plus 1 and the column number is a plus 3. So b plus 1 is row, a plus 3 is column. Now as I said, the column of the first matrix has to be equal to the row of the second matrix, then only multiplication is possible, otherwise it is not. In any kind of multiplication. Okay, if xy is existing, a plus 2 has to be equal to b plus 1. xy is existing. That is, a plus 2 is equal to b plus 1. This is our first equation. Now, yx is also existing. That is, when you multiply y and x, the column of y should be equal to the row of x. That is, a plus 3 has to be equal to a plus b. First one was a plus 2 equals b plus 1 for x into y. But y into x, these two has to be equal. That is, a plus 3 has to be equal to a plus b. A plus b. And it's clearly seen from the second equation, b is 3 because a gets cancelled. Now a plus 2 equals b plus 1. So here you can write it as b minus a as 1. B minus a as 1. And this is a you can just cancel b is directly, you can see b is 3 here. So b is equal to 3. Now when you put b is here, 3 minus a is equal to 1. So a is equal to 3 minus 1, that is 2. So a is 2 here, not 4. I'll just correct it. So what do we get? That a is 3 minus 1, 2. B is 3. So we got the value of a and b. Now there are certain other questions also being asked. Find a and b. We have already found out. Can you say x and yx are of the same type? They are not of the same type, because I'll just give you an example. Because a and b we know. Now let us write, because we have to see the orders. X is 5 by 2, because a plus b is 5 and a plus 2 is 4. Y is what? B plus 1, that is 4, and a plus 3, that is 2 plus the 5. Now the orders are not same. The orders are not same. Give examples of matrices A and B such that AB is not equal to BA. A and B such that AB equal to 0 or null matrix, but A should not be and B should not be equal to null matrix. Third one, A and B such that AB equals null matrix, but B not equal to 0. Fourth one is ABC such that AB and AC are equal, but B not equal to C, and A should not be equal to the null matrix. Now all this comes with practice. This you cannot directly write these matrix. No one can write these matrix. This just comes from practice. When you do 50-60 questions like this, then you know how to do this. So let me give you an answer here. A is this matrix, B is this matrix. This matrix, once you multiply it, you can take any matrix. You don't use any, this matrix. You can use any matrix 2 by 2, and you see A and B and A will not come equal because they are not commutative. Sometimes it may come equal, sometimes, but most of the time, means 99.9% of time, AB will never be equal to BA. Second is A and B. Now, when A and B you want to be 0, then how do you do it? See, if you are making 2 by 2 matrix, then you put 2 here. That is at the first row and second column, cross intersection. For the B, you take the first row, first column. Put some value there. Okay. We have placed a 2 value here. That is first row and second column. In the second one, in the first row, first column, we have placed certain value. You can write any value. We have just put 2, 1, you can write 5 or 10, whichever. Because ultimately it is going to give you 0. And we just have to say that they are not also 0. So we have put 2 and 1 value. Third one, BA should not be equal to 0. AB should be 0. Same thing, I told you how you devise, how you choose A and B so that it becomes 0. Okay. But when you do B into A, but the formation will change and it will not come to 0. A and B we have specifically given certain value, we have placed certain value, other values we have given 0. So AB is 0. But as I said, AB and BA are not, AB is not commutative. AB into BA, AB into A into B into B into A is not equal. Okay. Coming to the fourth one, A, B, C such that AB is equal to AC, but B should not be equal to C and A should not be equal to 0. Null matrix. So you have this A, B, C. Now A is this, B is this, and C is this. Now you see, A we have kept like that. That is the first row, first column. The B and C, the second row and the last column. That is second row and the second column. We have placed certain value. One here, two here. Just to make it that B should not be equal to C because it is given in the question. Okay. But since we have made a B and C such that it will always give you A into B or A into C as 0. Because B and C we have not made it equal. One place we have put 1 and one other place we have put 2. So this is how it goes. Let A and B be the square matrix of order, same order. Does A plus B whole square equals A square plus 2AB plus B square hold? If not, why? Now very simple property. Just assume and know and keep in your mind that when you do A plus B whole square normal values, A square plus B square plus 2AB, because AB plus AB will come 2 times and AB and BA are equal. But when you do the matrix multiplication, AB and BA are not equal because the matrix multiplication is not commutative. So when we do A plus B whole square, just multiply each and every value. A into A, then A dot B, then B dot C, then B dot B. So A dot A you can always write as A square. B dot B you can always write it as B square. But AB and BA, they are not same because they don't follow the commutative property. So this is not equal. A plus B whole square is not equal to A square plus B square plus 2A. This is very true with any matrix because commutative property doesn't hold for multiplication. There are certain questions coming which are like that, like this one. See, the first one, second one, and even the third one. They have the same logic and reasoning that the commutative property doesn't hold. A plus B whole square already we have seen. Just multiply A plus B and A plus B separately. And the second one I'm showing you now, A minus B whole square, same thing you have to do. I'll just give you a hint of the second one. A minus B whole square, that is A minus B into A minus B you have to do. Now see, A into A is A square. Now A into B minus A into B, and then minus BA, and then B into B is B square plus B square. So A, B, BA are not equal, so you cannot cancel them. Okay, so it will be A square plus B square minus AB minus B. We cannot write like A square plus B square minus 2AB. Coming to the third one. Third one is A plus B into A minus B. Just multiply it. This is not also equal because again the same thing that the commutative property doesn't hold. Now A plus B into A plus B, because A plus B into A minus B we are doing. A into A. Then A minus B is minus AB, and B into A is plus BA. Then you have B into B is minus B square. Now essentially you want to cancel these two, but you won't be able to do it because AB and B are not equal. So you just have to write A minus B whole square is nothing but A square plus A square minus AB plus BA minus B square. That is the final answer. This is a separate entity. It is not what we have done already. 3 shopkeepers ABC go to the store to buy stationery. A purchases 12 dozen notebooks, 5 dozen pens and 6 dozen pencils. B purchases 10 dozen notebooks, 6 dozen pens and 7 dozen pencils. C purchases 11 dozen notebooks, 13 dozen pens and 8 dozen pencils. A notebook costs 40 paisa, a pen costs 1.25 rupees and pencil costs 35 paisa. Use matrix multiplication to calculate each individual's bill. First we have to formulate the matrix. And then we have to see whether we can multiply the matrix. Thus, we have to make the two matrix such that it is multipliable. Okay? So, let's just make it. Just see what is given in the question. The question is, we have 3 shopkeepers. So, without any notice, just write whatever is coming into your mind. A, B, C, 3 shopkeepers. So, I'm just writing A, B, and C. Now, every shopkeeper, there are 3 items being given. For every. And their numbers also given. So A purchases 12 dozen. So I am writing notebook, then the pens, and then we have pencils. Okay. So PN is for pen and PL for pencil. Now A's notebook, how much is there? It is already given 12. Now A's pen is 5 dozen. A's pencil is 6 dozen. Now this is B. So B has 10 notebooks. It has 6 pen and 7 pencils. C coming to 11 dozen notebook, 13 dozen pens and 8 dozen pencil. Okay. Now we just wrote what we have learned in the question, but actually it is a matrix. Matrix is nothing but the arrangement of numbers only. Okay. Now our notebook costs 40 paisa. Now the cost is in 40 paisa. So, and the question is 12 dozen. So just multiply each. The cost of dozen we are taking because the every value is given in the dozen. So 40 into 12, 1.25 into 12 and 35 into 12 you have to do. So when we multiply 40 paisa with 12 rupees, we'll get 4.80. 40 paisa into 12 dozen. Then 12 amount with 1.25. Then 12 into 35, you get 4.20. So this first matrix is already being made according to the arrangement. But the multiplication should be such that it is multipliable. That is, this matrix is 3 by 3 matrix. And the column number of the first matrix has to be equal to the row number of the second matrix. Then only it is multipliable. So we are writing this matrix. The second matrix can only be 3 into something. Okay. So 3 into something, 3 into 1, because it is given 40 paisa. We can convert it for 4.8 is the cost of first element, this notebook. 15 is pencil, and this pencil pen is 15, pencil is 4.2. So 3 by 3 and 3 by 1. When you multiply this, you will get 3 into 1. This is the final one. So you get 3 values, and that is what we wanted. Okay. So let us see here. First, second, 3 values has to come. So I'll show you to you here because it will take some time. I have given you the idea now. Okay. So this will multiply 12 into 4.80 plus 5 into 15 plus 6 into 4.20. That will be the first entry. Second is 10 into 4.8 plus 6 into 15 plus 7 into 4.20. That will be the second entry. Then third one is 11 into 4.8 plus 13 into 15 plus 8 into 4.20. That will be third entry. Now all these 3 entries we compute, and whatever you get, the first one is A's, second is B's, third is C. These are the bills. These are the amount 157.80, 167.40 and 281.40. The cooperative stores of particular school has 10 dozen physics book, 8 dozen chemistry book and 5 dozen mathematics book. Their selling prices are like this. Find the total amount the store will receive from selling all the items. So you have to make matrix first. And those matrix which are multipliable. That is, the column of the first matrix has to be equal to the row of the second matrix. Okay, the first thing is given is 10, 8 and 5 dozen. Now since 10 dozen physics book is there, so there we'll make a row matrix and we have to multiply it by 12. Every value has to be multiplied by 12. I'm writing it for books. So 10, I'm making a row matrix, 10 dozen, so 10 into 12, what is that? 120. Okay, 8 dozen, 8 into 12, what will it be? 96. Then 5 into 12, what it will be? 60. So this is our matrix. You can call it as B or whichever you want, or call it as X. Now the second matrix is the pricing. Since the pricing is already given in rupees, we don't have to change it. So the first matrix is 1 into 3. First row, 3 column. Now second matrix has to be 3 into something. Then only we can multiply it. See, if you do this 120, 96, 60, then this is 3 by 1. So the other has to be a row matrix. Essentially the answer is going to come same. Okay. But still there has to be a way multiplicity or multipliability of the matrix has to be considered whenever we are solving this kind of question. Okay. So now the second matrix will be simply, we'll make a column matrix and it will be 8.3 and 3.45 and 4.5. These will be the entries in the column. Just write it in the column. Okay. Now this is how, because 1 into 3 and this is 3 into 3 rows and 1 column. Now it is multipliable only, and the result has to come only one value. Find the total amount. So the answer is coming also. This is how we formulate. The answer will be 1 into 3 and 3 into 1. These two cancels, 1 into 1. There will be only one value. So B into P we have to do. So I'll just show you here. I'll give you the logic. Now how you have to do, you just have to multiply these two matrices. 120 into 8.3, 96 into 3.4 and 60 into 4.5. Just add them. And the final value you are going to get is 1597.20. This is the requirement. In a legislative assembly election, a political group hired a public relations firm to promote its candidate in 3 ways. Telephone, house calls and letters. The cost per contact in paise is given matrix A, cost per contact. These are in paisa. So this is all for publicity, telephonically, a house call or sending a letter. Now this is the first matrix. This is simply given as the column matrix. The second matrix is the number of contacts of each type of in the two series x and y is given in the matrix B. Telephone, house, letter for x and y series. Find the total amount spent by a group in the two cities x and y. So the answer should come only two values. So a matrix should be only two values. So just see the order, then we will multiply. Now essentially we have to multiply these two matrices, nothing else. Okay. So we have 3 rows and first column here. Here 3 row, 1 column. Here we have how many rows and column? 2 rows and 3 columns. So we cannot multiply A with B. We have to multiply B with A. A and B is not possible because the column of the first matrix is not equal to the row of the second matrix. But if we do B cross A, this is 2, 3, 2 cross 3, this is 3 cross 1, and 3 cross 3, 3 will cancel, and 2 cross 1, that is 2 values will come. That is what is wanted in the question also. Total amount spent by the groups in the two series x and y. Okay, let us take these two matrices and multiply, just multiply. Okay, so this is 1,000, 500, 5,000, 3,000, 1,000 and 10,000. Multiply this with the second matrix, which is A, 40, 40, 100 and 50. Please remember these are in paise. So let it be in paise. When we reach the answer, we will convert it into rupees. Now multiply these two. Okay, let me show you how we will have multiplied. See, 1,000 into 40, 500 into 100 and 5,000 into 50. Just add them. Now the second row and the first column. Second row and the first column. 3,000 into 40 plus 1,000 into 100 plus 50 into 10,000. Just add them. You get 3,40,000 and 7,20,000 in the x and y. But this is in paise. This is in paisa. So you have to divide it by 100. Just divide it by 100 and you get the 3,400 rupees and 7,200 rupees. Okay, this is for x and this is for y. A trust fund has 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide this 30,000 among the two types of bonds if the trust fund must obtain an annual total interest of 1,800 and 2,000 rupees. This is NCERT question. Okay, so how we are going to do it? First, we have to divide this 30,000 into two parts. So if 30,000 is there and one part we assume to be x, the other part will be what? 30,000 minus x. If the amount is given as 10, if you divide into two parts, one will be f, the other will be 10 minus 5, that is 5. Okay, so x and 30,000 minus x. These are the two parts. This is first matrix. Now there are 5% per year and 7% per year. This is the first matrix is first row, second column. The second matrix has to be made such that the row number has to be 2. Otherwise multiplication will not be possible. So 2 rows, one is 5 by 100, the other is 7 by 100 because this is the interest rate being given. You can write 5 by 100 as 0.05, you can write 7 by 100 is 0.07, but that will restrict our multiplication. You will see just now. Okay, let me give you this idea. The x into, we have to multiply these two, x into 30,000 minus x and multiply it by 5%, so 5 by 100 and 7 by 100. Keep it as 5 by 100 and 7 by 100 because if we keep like this, you'll see what is the problem we face. This has to be equal to 1,800 one time and the other time it has to be equal to 2,000. First part I am going to show you, 2,000 I'll just show you. Okay, x into 5 by 100, that is x into 500 plus 30,000 minus x into 0.07 or 7 by 100. This is equal to 1,800. This is what is given in the question. Let me just write this here. But multiplying with the point will be difficult here, or not difficult. No, it's not advisable. So just write it as 5 by 100 and 7 by 100 and take this 100 on the right hand side or multiply everything by 100. So I'm removing it, keeping 100 here. So we get some amount on the right hand side, 5x, and this is 7 3 is 21, so 21 4 zeros and minus 7x equals 18 and then 4 zeros. Okay, so this 21 4 zeros and 18 4 zeros, take it on the left hand side, and 7x minus 7x will be 2x. So 2x will be equal to, what do you get? This is going to be 3 and 4 zeros. 21 minus 18 is 3. We have 3 and 4 zeros. Okay, so this x will be equal to this 30,000 divided by 2, that is going to be 15,000. It is not 4 zeros, it is just 3 zeros. So I just have to change that, or guys please change that. So you get 30,000 minus 15,000. One is 15,000. So what will be the other amount? 30,000 minus 15,000 is what? So what do you get? 30,000 minus 15,000 is 15,000. So if the x amount is 15,000, the other will be 30,000 minus x, 30,000 minus 15,000, that is going to be 15,000. So one amount is this. This is how you have to divide. I hope you got the idea. So this is how the communication or this will work, because 1 0 is less. So this is just 50,000. Okay. Now this is the first part. The second part is same. You just have to equate not with 1800 but with 2000. Same thing remains. Everything remains the same. No change. Here you will get x as 5,000. Subtract it with 30,000. You will get 25,000. Okay. ABC is given. Verify that AB is equal to AC, though B is not equal to C and A is not equal to 0. So what you see in the question is essentially B is not equal to C. A is also not equal to null matrix. And A and B you have to multiply, and A and C you have to multiply. I will just show you, because this kind of questions we have done already. So just multiply these two and you will get the same matrix. That is, AB and AC will give you 6, 7, 18, 21, the same. But since neither B and C are equal, nor A is equal to null matrix, these two will come same. This is, I leave it to you. This is simple multiplication. AB and AC you have to do. Okay. Let me show you again. AB and AC will give you the actual value, similar value. Okay, this is all about this exercise. Thank you so much. Take care of yourself.